opened. So once this window open, you just have to click with open with Google Collaboratory. It is because I have already signed in with my account. So this is already signed in. So I can directly click on it and the Google Colab folder will open. But for you guys, if it
Sorry,
is not,
excuse me. Sorry for the
yes, please.
disturbance.
Yeah, please go
One
ahead.
of our attendees are asking to share again the screen.
To share which one?
Please share again, madam. He's saying that the code, it seems. Okay. Small, all are the small letters, right? Lowercase letters.
Yeah,
N
yeah,
E
everything
W
is
V Q
small.
V C.
Correct, correct, correct.
Okay. Okay. Go ahead. Thank you.
Thank you. So once you are opening this Google Collaboratory, so if you are having your, if you're not logged in through your Gmail ID, then once you click over here, you will be able to see one login page where you have to log in with your Gmail account. So this is what you have to do for the assignment one. So before going to that, let me first come to the assignment. I mean, first come to the material where we will start with the Python program. So what basically is Python? Python is a programming language. It is an open source. Like, having said that, I mean that whenever you face any kind of issues, whenever you want to find any code, everything and almost everything you will be able to find in Google. So it's all on internet. So this is an open source, and also it is a object oriented programming language. So if I mean object oriented programming language, then what do I say? I mean, what do I mean by oriented programming language? So suppose if you are having any experience with C programming language, then I think this has become a little bit easier for you to understand what I mean by object oriented programming. But even if it is not, there is not an issue. Object oriented programming language is something where we can uh, objectify the programming languages, objectify the different instances of the program. Say for suppose you have a building. Okay, so in that building you have different flats. So each flat is an object, and inside a flat there can be different flat, right? One can be 2 bhk, another can be 3 bhk, one can be 1 bhk. So these are the attributes of the flat. So that means these are the features of the flat. So when I'm talking about the apartment, that is my programming language Python. When I'm talking about the flats, they are the objects, each building blocks of them. And when I'm talking about the feature, the shape and the behavior of the flat, that I'm talking about the attributes of the flat. So this is a very generic view with which I am just starting with the Python. Before jumping with all the different objectives like variables, what are the input output data types, mutable operations. So before that, it is very important to understand what is Python. So by using Python, why it is Python? Why do I need Python? Can I just do it by using something else? Yes, it can be done. But if you do by using a programming language, it makes your work far better, easy for you to understand what you want and also to make in a structured way. That's what I'm telling structured, what I mean an object oriented programming language. So for now we will start with the different pieces, I mean the different objects of a programming language, that is Python. So first let us come to a variable. So the basic part which you will learn in any programming language is the variables. So what are variables? By the name itself, you can understand that variables which are not constants. So when there is something like suppose for I instantiate that A. Now A is an alphabet. Now I want to store some value in A. I want to store the value 10, the number 10 in A. So what do I have to do? So what is 10 and what is A? So when I'm storing the value 10 in A becomes my value variable, which is holding the value of 10. So that's what variable is, a location. It's an address. It's a name of something. It's an identity. So when I'm just giving some identity, suppose when let us come to that logic of the building. So in that building, there are different flats. In that flat, the room numbers are different, right? So one room number is 301, one room number is 302, one is 103. So what are these 103, 203 means? These are the variable names. These are the name of the flats. So I would give you 2 minutes, and moreover this one I would like to have a kind of, I want this learning to be a discussion way, not a kind of a monologue. So because discussion makes the understanding more perfect, so I would request everyone to just scroll up and down. I'll just give 1 minute to scroll up and down the entire this file, python file, and just understand the flavor of it. And
Miss Uponika,
yes.
actually your screen share has got stopped.
Oh, is it?
Yeah.
Okay, just a moment.
Okay.
Is it okay now?
Not yet appearing. Yeah, now it is.
Okay. So as I was telling, so just take 1 minute of time and go through the entire. This is just not a few lines. Just go through the flavor, and then we will continue. Like, what are the different things that you have seen? The differences from each line to another line, and how the representation happen. So it will become easy for you to understand. So just 1 minute. Okay. So could everyone able to get into this classroom through the code that I have shared? Hello?
One
They are
attendee
replying in the
is
chat.
saying yes. Yeah.
Sorry?
Two
Can you?
attendees responded yes.
Okay, that's great. So you have seen the differences, right? Like what from this point of code to this point, from this point. So what all these things doing? So now let us come each one of it. Okay. So if I consider x as my some variable name, I am just storing a value of 10 for that variable. So I'm storing the value of 10 for x, 2.5 for y, and hello world for s. Okay, so from our general mathematics concept, we know that 10 is an integer and 2.5 is a float variable, and this itself is a string. Like this itself is a form of is a group of characters which we call as string. So if I run this code, for running the code, you just need to give a shift plus enter, and if you run this code, then what is expected from it, that it will be saved, that is 10 will be saved to x, 2.5 will be stored to the variable y, and hello world will be stored to the variable s. Okay, now let's see the print, how what it prints. So see, if I print x, the value is x expected 10. And here by this function type, you can also get what type of variable it is. So as expected, the variable is an integer. And similarly for y, which is a float, the type of the variable is a float, and s is a string. So the class type is a str. So by this, you can understand the basic building block of the language, that is a variable, how to store the variable and how to print the variable. So whenever you are storing the variable, ensure that it is not like the other programming language where you have to give parentheses and few other codes to save the variable. It is just x equal to 10, the same way you write in the mathematics. Let's come to the arithmetic operations. Now for this x1 variable, I have put an arithmetic operation of 3 plus 5. Y1 it is 3 minus 5, and so on and so forth. These are the different values. These are the different arithmetic operations which are done on different variable name. So when I'm just running this variable, each of the value is just calculated and stored in the different variables. 3 plus 5, 8 got stored in x1. So and so forth for each and every values. Now for an example, if I just take a print of sum x1, I'll get 8 as my value. So for this, let's expect what is the output is 2. So it is just a division that it is doing. Okay. So percentile again means the remainder. Division is done by a single division sign. Percentile means the remainder. So when 14 is divided by 4, the remainder is 2. So these are the different arithmetic operations that we can do very easily by using Python. See, you are not even printing the statement, you are just writing the logic and you are just running it. So it is able to give you the value. Now let us come to the different comparison operation like equal to, then greater than equal to, and these are the various logics that we read in that we get to see in mathematics, right? So the same thing that we will be able to see in this example. So x equal to 2, I have stored the value of 2 in x, 3 in y, and then I am doing this operation. So first I am just checking if x is greater than 3. So 2 is greater than 3. The condition itself fails here. And then I'm giving a statement, I'm giving a word and. So this is a keyword here, and x double equal to 2. So x, if it is equal to 2, yes, this condition satisfied. But at the same time, when I'm using and, it has to compare both the things. I mean, both this logic. This is logic 1, this is logic 2. When my logic 1 itself is failing for an AND gate, the logic 1 fails means the entire logic fail. So let's see what the value gives. So it's a false. And the type, whenever we are giving some comparison, whenever we are giving some logical operation for which is stored to a variable, the variable itself is a boolean variable. And for a boolean, the two only values which we can get is a true or a false. So now let's check with the immutable and mutable data types. But having said that, what do I mean by mutable data type and what is immutable data type? A mutable data type is the type which exists, which has its existence even if the data gets swapped. Just for an example, if I tell a equal to 3, fine. So what is the value? I mean, what is the type of a? A is an integer. Now I'm assigning, or well, I can say it is a reassigning the value of a to a b, that is to another variable. Even if I'm doing it, the b is also getting assigned as an integer variable because a is an integer. To clarify this, when I am assigning an integer to a variable, that variable type become an integer. When I'm assigning that variable to another variable, then this new variable also takes the type of the variable it was assigned. So am I clear? So it is like when I am doing a variable initiation with one particular data type and then I'm reassigning that variable to another variable, it takes the same data type. That is what mutable type means. Immutable is which does not take the same data type. That is an immutable type. Now, what do I mean by a ID of A? Now, for an example, for everything, for every variable, it has its own address. Uh, let us come back to the same example of the flat and the apartment. So in the apartment, we have understood that 301 is a particular variable name. That is, it is a particular name of the flat. But it has its own location, correct? So when 301 has its own location, we can also expect when I'm giving a particular 3 for this particular 301, the location is also the same because it is situated in the same place. So that's how it is an address of a variable. ID is nothing but the address where it is located. It is a reference. Now, these are certain examples where you can see whether it is mutable, immutable. So see, if I just make a equal to a plus 1, and that means I'm just making it, I'm just adding one value to this a, and now I'm checking if id of a is equal to id of b, but now it is becoming an immutable. That means a is no longer what it was. Now a has become 3, sorry, a has become now 4, and when I'm searching that when if a id is equal to the id of b, they are not same because b it's still 3 and a has now become 4. So that's why they are two different locations. Now here it is a list data type. List data type we will anyway come in the later part where we will talk about list and few other important concepts of Python. So before that, I would go with this example. This is almost the same example that we have gone through. So as we have uploaded this as an assignment as well. So these are few of the codes that you have to explore. And okay, this is important. When what is the function of this pop? Pop always means a delete function. What do I pop out? Suppose like if you have a stack of something and you are popping it out, it means that it is deleting the last element. Okay, so for an example, if I have a list of 1 2 3 and if I'm popping out, which one I'm popping it out? The last element of it. So anyway, this example, we will come with the list concepts and the later on part. But before that, I would come with the different data types. So this is an integer data type. Okay, so even if you are, see, data type conversion is very important. Suppose you have a string and you want to convert that a string into an integer, and if you have a float and you want to convert into an integer, what is the way to do it? The simple way is to write the name of the data type which you wanted to convert. So for this one, for this example, this is a string. If you can see that which I have passed through the function, this is a string, that is 34 is in a string format, and this I want to convert it into an integer. So once I write integer and in parenthesis I give this 34 as a string, I would get back 34 as a type of my integer. Now see, inside this I can see it is 34.56, which is a float variable, float value. And when I'm passing it through the data type str function, this will give me an str value. See, it is giving you a string. So if you can see the double, I can see the colon, quotation, that means it is in the form of a string. Now, this is an important part where you want to take a command line argument, like command line input. Every time when we code, it is not a good practice actually to hard code. I mean, to give you to give the input to give the values as the input inside the code. Sometimes you need to build some kind of code where you need to be very generic with your entire programming, and once the code is compiled you have to give the input on the basis of the user's choice, and then on basis of the user's input it has to do the expected work. So that's how when you want to build some projects in a real time project. So for that, how do we give this input? So this is a function by which we can give an input, x equal to input, and within that parenthesis, so this input function will take an input value, but ensure that whenever you are using this function input, it is taking the value in the form of a string. Suppose I'm giving 10, so if I run this, it is asking for me to give an input. So let me give 10 and I print 10. So it is 10, and I'll show you what is the type is string. So the value that you are always give as an input value through an input function is always received in a form of a string data type. So in case if you want to deal with this kind of values in an integer where you need to do some addition subtraction, then you need to convert that value to an integer by doing this. So just give int and then do this x. So this you will get your value into a form of an integer. Now these are the simple printing statements by which we can see how the print option and the different other function works. And then we will go with the conditional statements. Conditional statements, something if I just consider, say for example, if it is checking the positive or negative number, say for example, if I am running this code and I'm giving some negative number, say -9, and then I'm running y, and why does this line is coming from? Because y equals to integer x, as I said before, that whenever your input is coming, it's in the coming in the form of a string, so you need to convert your string into an integer. So when you're converting your string into an integer, after that you are storing into a variable y. Now this y is having an integer -9. Okay, so when I'm running it, now y is stored with an integer -9, and if I'm printing the type, if you can see, it's an integer because it got converted. Now for this statement, if I run this loop, negative. So how this logic I mean this conditional statement works. So if for an example, if you take this example only, like say for suppose if y is greater than 0, print positive, else print negative. That means I can say here, if the value of y which I have considered as a which I have stored as an integer value of -9 is greater than 0, then it will do some operation. Else, that means if y is not greater than 0, else itself means if y is not greater than 0, then it will do perform certain option. So this is just a simple, very basic way of showing the conditional statement of if and else. But in any other use case, it is only the way how you have to write a conditional statement. If the condition, this is your condition, this is very important, this colon. For this Python programming languages, the only thing that you have to make sure is an indentation. What is an indentation? It is that whenever you are giving a colon, either be it be a conditional statement or it is any loop statement, you have to give this colon. And once you are giving a colon, the next line starts from the next tab space. So this is an indentation. Once your indentation is not there, say for an example, if I give this, let's see what it gives. It's giving me an expected and indented block. So the indentation error occurs. So it is very important to give an indentation. So this is my output. Now let's see how this structure works. See, for an example, if I now this is the case if yes or no kind of case. If it is positive, else it is negative. So, for an example, you have multiple condition. You may have a grading system where the results have come, and if it is more than 80, it is A grade. If it is less than 80 but more than 60, it is B grade, and less than that, it is C grade. Something like that kind. So for that, whenever there is a branching, I mean multiple number of condition statement comes, then you have to consider an elif statement. So how that elif statement work? This is the syntax. So for an example, if I give an if and I write, maybe I'll just do this example. Okay. So if I give score, okay, I have given y over there. So let us consider y only. Score equal to some, I want to give it a 75. Okay, so now I'm checking if my score is greater than 80 colon, and then it will print grade A. Okay, and then elif I give one more condition, score greater than 60 and score less than 80. Print grade B. Cool. Now I give an else, it will print grade C. Okay, so my value of score is 75 and I have written a logic. Let's see what it prints. Yes, because my value is 75, which is less than 80 but more than 60. So I have got grade B. So this is how this elif structure works. So what I want in the next session when we will be doing the assignments, you have to come up with this kind of, like when I give any kind of syntax, just write a simple code for the syntax. If at all you are facing any kind of doubts or any kinds of you are stuck with something, just put it as a comment in the class group, in this classroom group where you will be having lots, you can see over here assignment, and once you open through this you can give a comment in this one inbox. So you can just comment over here if you are stuck with anything else, because it is very important to explore the syntax with your own codes. And something with the while also, let us explain the looping structure. Why do I need a loop? First thing, I need loop because I don't want to do a donkey work. I don't want to do a simple thing again and again. I don't want to write a very long code having the same small codes again and again 10 times. So if I'm telling you print a number, print 10 numbers from 1 to 10, so are you going to write from print 1, print 2, print 3? No, right? So you are going to give some range from 1 to 10, print the numbers. Simple. So for that, the this has come, the looping structure has come. Now for an example, if I say that I want to print 20, first 20 odd numbers. So when I'm telling first 20 odd numbers, I also mentioned that it has to be a looping structures because I told first 20. And when I said an odd number, I can also, it also means that I want something a condition, because when I'm looping from 1 to 20, it will remove 1 numbers from between, correct? So if I start from 1, so it will take 1, it will skip 2, it will come to 3. So that's how the logic builds, that you are just not doing a loop, but also you are doing some operation inside the loop. So this is how you can consider the different blocks, so by which you can go and extend your operation into different conditions. So for an example, if I take this, let's suppose print 10 numbers in descending order starting from a given number x. So when I'm talking about given number x, first my work will be to assign x. When I'm talking about given number x, my x need not to be an hard coded value. It can be an input value which I can given as an user input. And when I'm telling descending order, that means from the last, it has to come the 10 numbers. So see, if you can see here, y is considered as an integer value of x, because x is a string, as I have told. So now I'm printing y. Say for an example, if I have considered y as a value of, say for suppose 30. 30 is in a string format. I have taken the 30 into an integer value and have stored it into a y. So now I'm printing it will come to the next statement. It will print y. And then this operation is happening. What? That z equals to y minus 10. That means it is doing 30 minus 10. That means z will have an integer value of 20 stored here. Okay. Now if I print z, I'll get 20. Correct? Now what am I doing here? This is this is what a looping structure. This is a while loop. So there are three different types of loop: for loop, while loop, do while loop. They have the three different use cases. Now, for an example, if I'm using a while loop, it is giving me while y is greater than z, correct? So there is some condition. So it's very important that when you are giving a while loop, you have some condition. Without condition, you can never give some looping structure. So y is greater than z. Y value is what? Y is 30. And z is what? 20. So yes, 30 and 20. 30 is more than 20. It will print 30 and then it will keep on printing one number less than that. That means it will first print 30, then it will go, y will become 29. It will, so when I'm just exiting from the loop, it will again get into the loop until and unless this condition gets false. That is how a looping structure works. It will loop to this operation. This operation will keep on happening until and unless the condition gets false. So this will become 29, y is stored as 29, it checks if 29 is greater than 20, condition satisfies, it comes, it prints 29. Again it become 28 and go so on and so forth till it reaches the value of 20. Once it reaches 20, it prints 20 and it becomes 19. When it becomes 19, it goes back to the looping structure again, because here it doesn't know that whether it has to go or not. When it go back to the looping structure, it checks the condition if 19 is greater than 20. Here the condition does not satisfy. When the condition does not satisfy here, it does not come inside the loop. So we have all the printing done from 30 to 20. That's how a looping structure works. That's how a while loop works. The same thing happens with the different for loop and do while loop. So this I keep it for you to execute when you will be doing the assignment. Okay, so here it is some string operations, because we already have strings. We will be talking about strings in another 2-5 minutes. So okay, so let us say what is a string. A string is a very big domain. If I am talking for any Python or any programming language, just not Python. So when you are talking about string, it is a group of characters, and when you are talking about characters, it is a lot number of concepts. It has a lot number of operations. The string can be modified in many different ways. Okay, so for an example, the name, if you consider a name apartment, okay, so I can say APA R, T, M, E, and T. There are 9 characters. So these 9 characters, one you can consider the entire string into a uppercase, or it is in the lower case. You can consider it in any way, or you can consider it into a combination of it. Maybe the first letter is in uppercase and the letter is a lowercase. So you can change the cases. So there are various operations of the string that we can consider. So the first important thing that we will see in the string is how to write a string. That's the most important thing. A string is nothing other than that a list of numbers, a list of characters. Sorry. If you have a list of characters, say for an example, I have a list. Okay, so this list is just a storage. Okay, where you are just storing some characters. If you are storing characters, it is a character list. If you are string list of characters, if you are storing some numbers, it is a integer list. So this is how the data type of the list is getting identified. Okay, now for this list, vowels list, I have stored. This is how you write a list. Okay, vowel, this is the name of the list, this is the variable name, and you have to give this third brackets, and inside third brackets within quotation you have to give, because just because these are characters you have to give the quotation. Even if it is an integer, you need not to give the characters, you have to just write the numbers like 1 comma 2 comma 3 like that. So you are just writing the characters and you are making something like A, E, I, O, U. So it's very clear to see that it is a list of the vowels. Now list index operator. This is the index operator of a list. It starts with a 0 and index is an integer. So what it means is the first value of the list, that is A, the index value is 0. So it is a 0th element. So forth in the next follows, it is the first element, second element, third element, fourth element. So the index value always starts from 0 and it goes on. Okay. So if I am printing the vowels list, that is the name of the list of 1, that means I am telling I need the first element of the list. First element means this one. This is the 0th element. Okay. So when I'm printing this, I should get E. Okay. Now there is a very important part in the list in a string also, that is a slicing operator. Sometimes you need not to see an entire list. You just need only few characters of the list. Suppose for an example, welcome or welcome to the world of Python. You need not to use this entire string. You may need only the first 5 letters of the string. How do you do that? How do you cut short your how do you divide your string? To do that, you have to give some numbers here. What are these index numbers? From which index to which index you want a string? Suppose I have a suppose something I have an entire string. For an example, A, E, I, O, U. So this is my list, and this I want only few elements. I don't want the entire list, only few elements, and these are 1 to 3. Now, when I'm telling 3, this third element, according to the slicing function, it will take the element before the third element, the n minus 1. So, when I'm telling it is 3, that is the third element, it will take this till the second element. And the beginning index starts from the first element. So, my first element is E and my third element is O. But it will take only till n minus 1, that is my second element, which is I. So if I print this list, it will take only E and I. That is only from 1 to 2, 1 and 2, not till 3. So whenever you want to take 5 values, just make sure your beginning element is the element that you want to start from, and the end value is always your n plus 1 value, so that it will come to this minus 1. So it will just subtract one value less and it will give you that string. When you are giving a minus, that means when you are giving minus 1, you are just moving backward. So how you are just moving backward? Suppose I want to move back from this part to this part of the string. Okay, so if I'm giving minus 1, I will get a U value. So my U is the first element from the backward side. Now from here, it is not as important, it is not essential to count from the 0. 0 is always this one. 0, 1, 2, 3, 4. Again, this is -1, -2, -3, and so on and so forth. Okay. So for an example, if I give an example like colon -2, and one more thing, if you want to take, suppose like I want the from the fifth element onwards, I want the entire string. So you can just cut short the entire string by using a colon. Say for an example, if I give an example, the same thing, 1 colon. So what am I expecting to get? So from the first element, I will get the entire list. So if I get a colon, now let's do this, colon and then 3. So what am I supposed to get? I would get from the first till the third. I mean, third is here my second element, n minus 1. If I write 3, that means it will take the second element. So A, E, I is the expected. Okay. So the similar is here. So if I take from -2, from first to -2, so my expected value will be AEI. So if you can see here, it is colon to 3 is the same value which is similar to colon to -2. Okay. So if I modify here, see for an example, I have a list where I am talking about 1, 3 and 4. And then I have a num list where I am making this, my first 0th element is 1, right? Now I want to change the value of this 1 to 2. So this 0th element, I'm initializing it with 2. So when I'm writing it 2, let's see what's the list comes out. 2, 3, 4, because it got modified. And by this you will be able to modify 2 different numbers and so on and 4 different examples are there. So you just go through this example and explore how it is happening. So yes, now I'll come with the range of the list. Suppose you have a list where you want to initialize first 10 numbers. So you can also give a function called range function by which you will be able to find 10 from first 10 numbers from 0. So again, when I'm giving 10, it will give n minus 1. So 0 to 9 is the first 10 numbers. Okay, and this range function also comes up with the beginning value, the ending value, that is n plus 1 value, and the value, the count value. That means at what interval the values has to be. If nothing is mentioned, that means it will take 1 as by default. If something is mentioned, say for an example 2, that means I want values from 2 to 10 with an interval of 2. So my values is 2, 4, 6, 8. Okay. First odd numbers. So these are various examples that is shown over here. Yes, there are various operations in list that you can go through, that it is append or extend. If I append, suppose I have a string 45, 8 and 5. What is appending means I'm just putting something, I'm just adding something to the list. So when I'm adding something to the list, it is called as append. So I'm appending 6 to the list. So 6 got appended to list 1. Now I'm doing list 1 dot extend. So I have another list which is having the number 859, and this list got extended, got added, they got they have got clubbed together with the list 1. So what is my expected value? So if I'm seeing first list is 4585, which is printing that list, original list, it is appending the value with 6. So it has become appended to 45, 8, 5 and 6. And then it got extended, that is 45, 8, 5, 6, and the another list which has got extended. So these are the various list operation. This two is just an example. You can also get delete operation. You can also get other few also operations that would be very helpful when you will be working with list. So I will just come with the second material where there are few different examples of the string, how to handle string. So if you can see, I have just written that initialize string welcome to ML using Python workshop So I'm printing this string. So the string will be expecting this this entire value of the string is stored to the variable s, and here I'm printing the same thing with s1 variable. So my s2 is also the same thing. I can see here, see, if you can see here, welcome to, there is a difference in the quotation mark. So this is my entire string. Now here ML workshop is ML using Python. This is under quotation. So if you're giving double quotation together, you will be getting one particular string. So this is a string inside one string. So this itself is a string inside which I'm keeping one more string. Now this is my another example where I can use this double quotation and I give a single quotation. That means using Python's workshop. So now it is not giving any quotation anywhere. Okay, so these are the different examples how to represent a string. So if I want to access any variable of a string, this is how you want to do. Suppose for an S1 string, which is this one, I want to get the 0th character. So if I just do a 0th character, it will give the expected W. For the S2 string, which is this one, I want the -1, that is the last character. My last character is P. So that's how it is. And as I was telling that how to do the slicing programs, how to do the slicing so this is how it is. Welcome to ML using Python's workshop. And if I take the second string and I want to print from the second element till the seventh element, I need to give n+1. So I will give 8. And here I will see second element is 0, 1, 2. From L it will start COME. So let's see how far it goes. It goes to LCOME. So from second element to seventh element, this is the string. I'm printing from the second element the entire string. From the second element to the entire string except the last two variables. So workshop, the last two characters. So the last two characters is OP. So I can print till this much. So these are the various ways how you can do a slicing. You can just you can just divide your string. So these are the operations, and easy operations in a string. The Python, in Python it is very easy to handle strings because it has its own built-in functions. So in if you give a length function, it will give you what is the word count, I mean what is the length of the entire string. And if you just want to transform your string into an uppercase or lowercase, there's just the function to do that. So see, you can see in the entire string S2, there are 37 characters. There's a total 37 characters. And if you take the entire string in the lower case, this is the way, this is in the uppercase. And yes, this is one more very important. If you want to replace one character with another character, in S1, that means in this string, I want to replace W with T. So how it is happening? See, welcome to some telecom and something happens. So is this now important part is string data type is mutable. That means if I can change the existence of a string and swap its existence to another string. So for an example, if I have a string 3 which is JNTUA Kalikiri, and then if I'm printing the string and ID of the string, will it be able to give return a new string? Let's see how it happens. So it will print the original one, and then I am just making U with O. Okay. So let's, here I make I. So can you see if I'm replacing my I, that means my string 4 is the third string where the I character got replaced with O character. So it is giving me this a new string. And do you find the ID of the two strings same? No, the ID is not same. So that's how you will get your answers. So if you have a list of word in the string, how to split? Yeah, the split function is very important. If you go ahead in your ML and DL the rest part of the workshop, where you will be seeing how to split a particular text into different words when you will be working with a text data or something. So if you are having S3, so this after splitting you will get two different words. So this is how the string works. Now we'll come to another part, last but not least, the dictionary and the set. So first, to talk about dictionary, I can say it is just like it's just like a name book. Okay, just you have some name and you have some value with it. Say for an example, if you are considering a phone book, you have a particular person name associated to that person. What is the phone number of that person? So that name which is holding some value of that particular person, that is called as key. Key. Key is nothing but the name of the variable, and the value is itself carrying the value. So we consider a dictionary with the second brace. So if I'm having a braces, empty braces, this is how we initialize as an empty dictionary. That means I am initializing a dictionary called phone book, which is having an empty braces. And then in this, I'm going on adding the elements to it. When I'm talking about elements, I mean by telling both the values and the key. So for the phone book, for the key Goswami, I'm giving some variable. So this is the phone number of this particular person. So on and so forth, two, three other different records I'm taking. So it is the group of records. Okay. So a particular person, what is the score? What is the result for a particular person? What is the phone number? So these are the stack of records that I am collecting for a particular in a phone book. Now let's print the phone book. So when you are getting a representation of dictionary, this is how it looks like. The key will be represented in a quotation, and a colon will be representing that the value is this is the value for this particular key, comma the next record, comma the record number 2. This is how it goes. Now I can modify dictionaries. How do I modify dictionary? I can just print the phone book of Reddy. That means how I'm doing this, I'm just taking the value of the particular person, the value of the particular. See, if I'm just taking only this, I'm just doing phone book of Reddy. This, it is returning the phone number of that particular person. So to get the value of the person, you just need to give the dictionary name along with the key value of the person, along with the key value of the dictionary. If I want to update, so previously the value was 123456891. Now I want to change the value. So for this particular person, for this particular key, I am giving another new set of numbers. So this is my new set of number. It got modified. So now I'm printing it. It got modified. So I'm creating a new phone number. So I'm just adding to a new key. So how do I do that? The same thing, the way I have done this, another three. The same, the phone book, now it is a Mirza 444. Now, if I'm printing the phone book, now I'm getting Goswami, Reddy, Tendulkar, as well as Mirza. So it got added. Okay. So now I want to get only the keys. The keys will be this one. And I want to get only the values. So you have to give, to print your keys, you have to give the dict dot keys, I mean dict underscore keys, and dict underscore values will return the values of it. Now, if I want to delete an entry, how do I delete it? So if I want delete, this function will be able to delete an entry from a phone book. So print phone book.keys. If I'm delete, I have already deleted the Reddy's record. Now let's see which one is there. So the remaining three will be visible here. Now I have talked in the before the last Python notebook also, like pop function is there to pop out, that means to delete from the last flow. So here I'm popping out Goswami. So if I'm giving a particular name, I'm giving a particular key, it is popping out that. But if I'm giving only pop, it will pop the last one. Say for an example, now it is popping out Goswami, and it is giving me the result of Tendulkar and Mirza, the remaining two. But if I'm popping out, let's see what happens. Sorry. See, pop expected at least one argument. So in the list, when you are popping out, it has to give at least one argument. So at least one of the key has to be there. So we will just write one of the key. Acha, you have to run. So when you're running, this is also make sure when you're running one piece of code, make sure your previous piece of code is also getting run at first before that. So this is how it is. So whenever you are just deleting the any entry from a particular code, you are just you have to give at least one argument of that particular key value. Now, for an example, if I'm taking some items, okay, so for X and Y in the phone book item, and I'm printing the phone numbers. So whatever the phone numbers are there, I'm just printing. Suppose I just do not want each and everything to be printed. Like for this example, if I just hard coded this and this is what, I don't want to delete one by one. So I just want to delete the entire thing with a range function. So for that, you just give a for loop. So for loop name, comma phone number in the phone book dot item. So whenever you are just giving this value of item, this function item, it itself itemize the entire phone book and take one record. So here the records are nothing but your one by one record that is happening. So this I'll leave for you to do it in the assignment. And yeah, now let's consider set. What is a set? This is the same thing that we have done in the set theory in mathematics. So this is the last concept that we are going through. So yes, so in the set, if we suppose for an example, if I'm giving a family of the set Mr. and Mrs. Now see here, no, just notice here, here the set starts with this parenthesis. Okay, so when you are initializing a set, it is through a parenthesis. Dictionary is by the second brackets, and list is by the third bracket. So these are very important when you are initializing any kind of this set, list or dictionary. So this is how you are initializing a set, and inside a set you are again initializing one list which is having the two values Mr. and Mrs. Now in this I'm printing this family, the set of the set, and I'm printing the address of this set, and then to this particular set I'm adding one more element, that is master. Okay, now let's see how it happens. So, so Mr. and Mrs. Right? So it gives an ID of the particular set, and after addition, it has become master, Mr. and Mrs. So it got added. So it got added at the first. This is very important. Now, it in the list, it was getting added. When you have seen in the previous example, it got added at the end. Now in the set, it will be added anywhere in the list. So it got added in the first. Now what I'm doing, I'm just clubbing two different sets. I'm having a juniors. This is one more set. I'm having Miss, and master. And here, this is my family. This family L is another list. Okay. Now this I am clubbing it with this. A family L dot extend with juniors L. So this list I'm clubbing it with this list. And see what it happens. I already have this Mr. and Mrs. Now, after getting clubbed up, it got Mr., Mrs., Miss, Master. So, in the list, if you can see this two difference, the output difference, after union of a set, the duplicate values get deleted. Only unique value stays. Like master, one Mr., one Mrs. Even it gets union with the previous set, it gets Miss, Master, Mr., Mrs. So the keys are unique. But here, if you see a list extend, that means when you are seeing the clubbing of two different lists, you can see the duplicacy. I mean, you can see the addition has happened with no unique key. The keys are duplicated. Okay, so this is a major difference between a set and a list. So now, as we have crossed some time also for the next session, so we will start with assignment 1, where I would expect you all to go to this section in the classroom and open each one of the assignment, which is the same thing that I was showing from this time. This two assignment, just run the codes, explore it, and most importantly, understand the code before just not only running it. So run the code and understand before running, and whatever, if you have any doubts, explore. And also, if you are stuck with something, just write it into in the stream. For you can comment over here anything if you want, or else for a particular session you can also comment. If you are getting insight to it, you can also comment. So yeah, so let's do that, and then we will see how we will sort out the different doubts that you guys are having.
Hello, Miss Uponika.
Yes.
Can you see the chat window? Chat.
Yeah, I can see.
Yeah, some participants are posing questions. Would you mind their
Okay.
answering?
Yeah, sure.
Thank you.
Ma'am, do we have to upload the PDF of particular class? Yes, you have to upload the PDF. In the same section, you can upload over there. Can we please get the Google Classroom link again? Yeah, sure. I will put over here. Just go to, wait. Uh, yes, Mr. Rajarama Reddy, you can just go to in Google. In that there will be Google Classroom. So in that, if you join any of the class and then give this code, this one that I have shared right now. So if you just paste this code, you will be able to come into this classroom. Anyone had any doubt regarding the class that I have taken? I mean, regarding the Python, the two notebooks that I have discussed? No, sure. I mean, to do with the assignment, you will get the two assignments. So just understand the code, run the code, and as I was showing you some example, like how to, say for an example, if there is one syntax, just write some code for the syntax and try to make some changes in the code and see how it is affecting the output. Can you explain which are mutable? Yeah, mutable and unmutable objects, as I was discussing, these are whenever you will see, suppose I have a equal to 3. So I have initialized the value, integer value to a. Now, for an example, if I am initialize that value, that variable a itself to another variable, say that b equal to a. So it is able to take the same value, it is able to swap. So b is taking the value of 10, right? So this um this this transition from a, which already had the value 10,
Miss
and
Miss Uponika, your
yes,
screen is not shared.
I'm just I'm just
Okay, okay,
explaining.
okay,
Yeah.
okay.
So whenever you are just making one variable stored and that variable getting stored to another variable, so in that situation it is mutable. So it gets transformed. Yes, in list set and dictionaries, these are the storage. I mean, this is a kind where you are storing multiple elements. In a list, you will be having number of elements, or even it is possible that it will have at least one element. So in that case, you need to figure it out like how the list is getting stored. I'll show you an example. Just a moment. Okay, my screen is visible.
Yes, it is visible.
Okay. Yeah, see here. So for this, if I'm printing the ID of the family, okay, where family is a set of the different characters, whatsoever it is. Now, I'm adding a family, I'm adding an element to a family, okay. Now, I'm checking the ID of the family. First one is giving me an ID 712, okay. Now, if I'm adding some value to it, it is giving me the same ID because I'm adding it to the same set of characters, same set of string. But now, if I'm changing, I'm taking this, I'm doing an union function to the set. So when I'm doing a union function of family with the juniors, now I'm clubbing these two set together. So when I'm clubbing these two set together, now what is the ID of this set? It is something different from the previous one, right? So this is non-mutable. So when it is different from the previous set, after getting added up or after getting swapped, at that time it is as non-mutable. We do not assign the result to original family. exist without. I didn't understand the question. If we do not assign the result to original family set, okay. It's not clear, Naushad. Can you unmute yourself and just clear the doubt?
Uponika, we have disabled unmuting by the participants.
Oh, okay, okay.
Uh, uh, I just do one thing. I'll just elevate him to panelist so that he can ask the doubt. Okay, let me do
Okay.
that.
Yeah, thank you.
Yeah. Mr. Rahim, you can ask your doubt. You can unmute yourself and ask the doubt. As your question in the chat is not clear to the speaker. Uh, Otherwise, you just type the question again. No response.
Okay, meanwhile, any other questions? Anyone else? Or everyone is able to open the classroom link, right? And able to go through that assignment 1 and assignment 2. I mean, assignment 1, those two folders. Okay. Okay, so let's take half an hour. So now it is 3:23. So let's take in half an hour, and meanwhile you just carry on with the assignment 1, which I've shared, and run the codes explore. And for anything, just because you need to upload your PDF, right? So make sure you are just at least exploring one syntax throughout the assignment. So just do it. Take half an hour. We'll connect back to half an hour and we'll continue with the rest of the questions.
Everyone, please work on the given assignment for the next half an hour, and the speaker will come back and clear your doubts anymore if there. So. Please work on the given assignment and we'll resume at 4:15 p.m. with upcoming session. Still any doubts from anyone are accepted. Will be cleared. Naushad Rahim has raised his hand. Do you have any doubts still existing? Can post in the chat session.
Meghna, you need to upload the assignment in the Google Classroom. In the classroom where the classwork section is, and in the assignment one section, you need to upload there.
Marley Maria Bernandez Rebuzzi Velasco received her BSc and MSc degrees in electrical engineering from the Pontifical Catholic University of Rio de Janeiro, Brazil, and a PhD degree in computer science from the University College London. Dr. Velasco is the head of the Computational Intelligence and Robotics Laboratory at PUC Rio. She is the author of 4 books and more than 400 scientific papers in the area of soft computing and machine learning. She has supervised more than 35 PhD theses and 85 MSc dissertations. Her research interests are related to computational intelligence methods and applications, including neural networks, fuzzy logic, hybrid intelligent systems, neuro-fuzzy, neuro-evolutionary, and fuzzy evolutionary models, robotics and intelligent agents applied to decision support systems, pattern classification, time series forecasting, optimization, and data mining. So we are very privileged to have you, madam, for this session. Thank you for being with us. Please start your session, madam.
Thank you very much for the introduction and for the invitation. I'm really glad that I can give this talk to all of you. So I'm really pleased. Thank you again for the invitation. I will try to share my screen.
Yes, ma'am, you can share.
Okay. Who can? Okay. So let me see. Can you see my screen?
Yes, ma'am.
Great. Yeah. Well, so again, thank you very much. This talk that I'm going to give is about the work that we have been doing. Actually, we are still working on this topic, which is neuro-evolutionary models based on quantum-inspired evolutionary algorithm. As she mentioned, I am from the Catholic University of Rio de Janeiro in Brazil, and I coordinate this research lab that involves computational intelligence and robotics, okay? And this has, the work that I'm going to present here is related to many previous PhD and MSc dissertations that I have supervised. I will give you a brief introduction why this topic is interesting, okay, in terms of why you need evolutionary algorithms, not necessarily evolutionary algorithms, but why it's good for you to have some algorithm to tune and build your neural networks, okay? And since these are based on quantum inspired, I'm going to provide a very brief description about these algorithms in terms of how do they work, okay? And then I'm going to present some of the models that we have developed in terms of different architectures, different structures of neural networks. And I'm going to focus more on the convolutional neural networks. And in this way, it's not called anymore neuro-evolutionary models, but more like neuro-architecture search that I'm going to discuss, okay? So basically, modeling the correct configuration of neural networks is really very time consuming. And now the problem in terms of deep learning and deep neural networks, this has increased even more the demand for tuning and building the architecture. It's very time consuming because the networks has increased in terms of number of layers, the configuration, types of different layers actually. So it's really hard to try to find the best architecture. All the hyperparameters of the neural networks like learning rate and others, like in convolutional neural networks, for instance, what kind of kernels I'm going to use. Also, what are the best features for me or the best attributes or inputs of the neural networks that are most relevant for me to create my model and many other things. So as I mentioned, so this is very time consuming and in the deep learning, this has really increased. And it's called now neuroarchitecture search, because I'm trying to use an optimization algorithm to search for the best or the most appropriate architecture. Okay? So in order to do this automatically and try to find the best architecture or the best model of a neural network, the use of evolutionary algorithms it has been common and has been done since many years ago. And why evolutionary algorithms are interesting? Because it's a global search method, is adequate to complex, multimodal, and non-differentiable surface. So when you have some optimization algorithms that are basically related to like gradient descent, these are more local search models and not global. So it's good to use some evolutionary algorithms because it will be less likely to be trapped in local minima and other advantages in terms of building the neural network model. However, the traditional neuroevolutionary models like genetic algorithms or others, they are also computationally intensive. Of course, it's something that the computer is going to do, is not human time consuming, but it's still, you need a lot of time to tune your neural network. And also, it's very hard to evolve all different configurations like architecture, weights, hyperparameters, and everything. And the larger the neural network, of course, you would need a bigger population and the time for the evolutionary process will be still higher. So these kind of algorithms might take a long time. So that's why the quantum inspire that I'm going to give you a very short introduction is suitable because it will try to reduce this computational time and reduce the evolutionary process in order to find the best model and the best configuration with less time, okay? So as I said, for you to understand the neuroevolutionary model using this kind of algorithms, I'm going to give you a brief introduction about how these algorithms work, okay? First, the binary representation, which is the first model, the quantum inspire model, and then I'm going to provide the real, because some neural network models like weights and other things, or hyperparameters, need a real representation. So let's see both kind of evolutionary process. This quantum inspire with binary representation, I'm going to increase here the pointer. I think it's better to see. Yeah. So this quantum inspire with binary representation is inspired by the concepts of quantum physics, okay? And basically the idea of superposition of states. So the chromosomes or the representation of the solution in the evolutionary process will be represented by binary strings, but as we will see, the representation will use this idea of superposition of states. But this binary is good, of course, it's built for combinatory optimization, not real or numerical optimization. So the idea is, instead of having a bit, okay, 0 or 1, we are going to use the quantum bit, which is actually the superposition of both states, 0 and 1, okay? And to represent this quantum bit, we use this representation where we have two actually numbers between 0 and 1, which represent the probability of observing that bit with the 0 value and the probability of observing that bit with 1 value. So alpha square and beta square are respectively the probability of observing 0 and 1. That's why it's called the superposition, because before you observe this quantum bit, you are in both states, 0 and 1, with different probabilities given by alpha and beta, okay? So you can represent this, and then you have alpha squared, the probability of observing 0, and beta squared, the probability of observing 1. And depending on where this arrow is, you will have a higher probability of observing 1 or a higher probability of observing 0. Okay, so if you have a representation of 2 quantum bits, you will have alpha and beta for both bits. And then you can represent all different states. Because when you have 2 bits, you have 4 possible states, 0, 0, 0, 1, 1, 0, and 1, 1. But with these 2 bits, you represent in one function, actually, all 4 states with their different probabilities. That is the idea, okay? So the quantum evolutionary algorithm with binary representation, instead of using bits here, that will be 0 and 1 for each gene will be represented by a quantum bit with alpha and beta. Okay? And then you have the evolutionary process, very similar to a genetic algorithm, for instance, okay? Where you initialize your, in this case, quantum population, and usually you initialize, since you don't know what is the best solution, you initialize with the same probability of observing 0 and 1. So each value starts with 1 over square root of 2. And then during the evolutionary process, this will be moved to 1 and 0, depending on the best solution. You observe these states, okay? You observe the 0 and 1. Then you evolve, and you need to update, as in the evolutionary process, you need to update the crossover, etc. And here you need to update the quantum bit. And this is basically, you don't need to pay attention to these equations, but basically, if the best solution has that bit with 1, so the update will be done in order to increase the probability of observing 1. That's the idea. So the evolutionary process will move this arrow in the direction of the best solutions. If the best solutions has the bit with 1, it will move in that direction. Or if it is 0, it will move in that direction. And this is the evolutionary process, okay? But as I mentioned, the binary representation is suitable for combinatorial optimization problems. But if you need a real number, if you need to evolve real numbers like weights in a neural network or hyperparameters like learning rate, momentum, and other things, this binary is not the best representation model. So it's better to have another evolutionary process with real representation, which I'm going to show you here. So basically, the idea is to create a representation, a chromosome with real representation. As we will see, it will reduce the conversion time, it will be scalable, and other characteristics. I don't want to waste too much time in here, but the real representation, as we will see, is more adequate for neuroevolution process and for neuroarchitecture search. So the quantum-inspired evolutionary algorithm with real representation now, it's not going to be a quantum bit because it's not binary anymore, but we need also a kind of gene that will represent all possible values that that specific parameter can have, like a weight. And we are going to use, instead of a quantum bit, we are going to use a probability density function to represent each gene in the evolutionary process, okay? So basically, we are going to have a quantum population that will be formed by, of course, quantum individuals, and each quantum individual will have a quantum gene, and this quantum gene will be a probability density function. Just to understand, it's simple, the idea, and the probability distribution functions that was chosen is basically a square pulse. And if you have a parameter that can range between -1 and 1, for instance, you create this probability density function that has all possible values with the same probability in the beginning. Okay, and the idea of the evolutionary process will be to find the best solution in this range. So this pulse will be modified during the evolutionary process, moving in the direction of the best solution. And of course, the area has always to be 1. So if this square pulse reduce in terms of the width, of course, it will have a higher value because, of course, the area here has always to be 1. Okay. So the quantum inspire with real representation has genes, and instead of now we have alpha and beta representing the probability of observing 0 and 1, we are going to have also 2 values here, but that will represent the center of the pulse and the width of the pulse for each parameter. So if these are weights, for instance, of a neural network, we will have for each gene the range of that weight, and the evolutionary process will change these values in order to find the best weight, the best value for each weight. That is the idea. So here is the whole process of trying to find the best configuration in the evolutionary process. It doesn't need to be only for neuroevolution, it can be for any optimization problem, where you have a quantum population. And this quantum population is, of course, formed by quantum individuals, and each quantum individual is composed of quantum genes with that mi and sigma. And this quantum population is actually observed into the classical population. Of course, the classical population is the one that I can evaluate. And based on this evaluation, I can update using quantum operators to change this quantum population in order to find the best solution. That is the evolutionary process. And here is basically very similar to the binary version, but now, of course, the quantum population will have real individuals, real representation. And we need to also to initialize this population, and we use those values. And usually, since we don't know the best region, we create square pulse for the whole range of that specific parameter. So if this parameter goes from -1 to 1, it will be a square pulse in this range. If another parameter goes from 0 to 2, it will be, the square pulse will be in that range. Then you need to observe, okay, and the observation is very simple. You have a square pulse, you have a random value here, and then you define, based on this CDF, you define the value that you observe, the real value, okay? And then after you generate the classical individuals, you use classical evolutionary process and using crossover and mutation, if you want. And then you need to update the quantum population. And as I said, the basic idea is to modify the pulses in the direction of the best solutions. So you shift the pulse and you change the width of the pulse based on the best solutions of the classical population. And this is the whole process. So this is a very brief introduction, but just for you to have an idea of how these values or how these algorithms actually can be used to evolve different architectures with different kind of representation. So we have applied this evolutionary process to fully recurrent neural networks, to feed-forward neural networks. These are also recurrent neural networks, which are called, it's from the group of reservoir computing, let's say, it's called equistate. And more recently to convolutional neural networks. I'm going to try to show you how this has been done with some case studies in all different architectures. So let's start with fully recurrent. In this case, we wanted to evaluate the quantum inspire with real representation, but to define the whole topology of the neural network. So I don't know a priori how many neurons I need, and also the connectivity among all these neurons. That's why it's called fully recurrent, because any neuron can be connected to any other neuron, as I'm going to show. And not only the topology, but we wanted to evolve also the synaptic weights of this network, okay? So the initial structure of the neural network, the only thing we need to establish is the initial number of neurons that we want. Okay, in this case can be 3, but the evolutionary process can increase this number if necessary, or reduce this number if necessary. And I'm going to explain this later. And of course, we have the number of inputs. This is based on, of course, on the problem. And all these neurons can be connected to all of them. And these connections and how they are connected is fully well implemented, or it's based on the evolutionary process. So this is completely free. It can be at the end a fully feed-forward neural network instead of recurrent, if there are no connections here. But initially we have this. Okay. And as I said, we have a special operator, we call it lesion, that from every n generations, this is a hyperparameter that we define, but the evolutionary process tries to remove a neuron, and it verifies if the error is below a certain threshold. So if the change in the error by removing a certain neuron can increase, but the increase in the error is below a certain threshold, so that neuron is not really important, so I can remove it, okay? So if the error is below this threshold, we can remove the neuron. And if I tried this remove of all neurons, and all neurons are important, we can add a new neuron. So that's how the process can increase the number of neurons in the neural network or reduce. And of course, if a new neuron is added in the process, the initial weights are 0, and then the evolutionary process will find the best weights for that added neuron. Okay, so this helps to find the best solution. So the basic structure of using this evolutionary process with the fully recurrent neural network is very simple if we are using the supervised training process. So we have the neural network we want to evolve. We provide the input data. Of course, we provide the target value that we want, since it is a supervised training. And based on the output of the neural network, we can calculate the error, and the error is, of course, the evaluation function that will be used in the evolutionary process to reduce this error and find the best configuration. This structure, this evolutionary process of a neural network, can also be used in a reinforcement learning way, where actually the recurrent neural network is using the evolutionary process and interact with the environment, and it changes the state. So we have an initial state. The recurrent neural network will, of course, provide outputs and will change states here. And we can evaluate the final state and use the reinforcement learning, if it is good or not, to evolve the process here and find also the best solution, okay? This fully recurrent neural network has been used in many different problems, but I'm going just to focus on one, just for you to see how this process can be done. It's a very simple control problem in the reinforcement learning process, okay? So I guess you know how the inverted pendulum works. So you have a car and you have this pendulum that can, of course, spin around this axis. And we want, of course, to control it and have it in equilibrium here, okay? And these are the equations, it's not important. These are the values that were used for these parameters in order to simulate this inverted pendulum. But the idea here is to find the neural network, the structure of the neural network, and the weights of this topology totally automatically in order to learn how to control this, okay? So the initial configuration started with 5 neurons. In this case, we have 4 inputs. This is based on the problem, okay? So we have the position, the speed, the inclination, and the angular speed. As I said, we started with 5, but this can be evolved, increasing or reducing. And the output, in this case, is only one output, which is the force applied to the car. And the initial configuration is all 5 neurons connected to all 5 of them. So it's fully recurrent, okay? And these are basically the parameters of the evolutionary process. So those that have worked with evolutionary algorithms can see that the idea of using quantum reduces a lot the number of, or the size of the population, because usually you have, well, much more than 5 individuals in a population, but because each individual can represent not only one point, but the region, because of the probabilistic representation of each gene. So we have a reduced population. And here is, for instance, how many generations we use in order to evolve the classical population. And also the threshold in order to define if an error will be removed or not. So if the error increased by 10%, then error can be reduced. And other parameters like the total number of generations, etc. Okay. And here is a comparison with other reinforcement learning algorithms, that in terms of the average number of evaluations to reach the equilibrium. And with this quantum inspired evolutionary algorithm with real representation, the average number of evaluations was smaller, the smallest actually. And the final configurations, as you can see, we started with 5, but at the end, the algorithm automatically reduced and found the best configuration with 4 neurons. Okay, and this is just the angle and the car speed in order for you to see that it reached an equilibrium. Then we also used these two, actually, not only the real representation, but we are going to see now that we are going to mix using a hybrid approach in order to evolve a feed-forward, very simple multi-layer perceptron here, but totally automatically using these algorithms. So in this case now we have a hybrid, because we are having a part of the chromosome will have binary representation and part of the chromosome will have real representation, okay? The binary part is to define what are the best inputs for my problem. So I don't know, I have many features and I want to do the feature selection. So the algorithm will find the most suitable features for the multi-layer perceptron in this case. And the binary part also defines the number of neurons in the hidden layer and which activation function is most suitable for each of the neurons, not only in the hidden, but also in the output. And the real part, of course, represents all the synaptic weights of the neural network, okay? So that's why here the chromosome has this white part is the binary, where we have a certain number of inputs in my data set. Let's say I have K inputs, but not all of them are really relevant. And I want the algorithm to find among these K inputs, what are the most relevant, okay? This is important, as you know, for neural networks, because with less input, I have a smaller architecture with less weights, and then I'm less prone to have overfitting and to have a bad generalization performance. So to find the best features is really important for me to reduce the neural network to the suitable configuration. We also have the active neurons. So I define the maximum number of hidden layers, but not all of them will be active at the end. So my neural network can have less than 8 neurons in the hidden layer. And this is the part of the activation function. For the activation functions can be hyperbolic tangent or the sigmoid. So it's a binary representation, either this or this, but for all the hidden layers, neurons, and for all the output neurons also. And this gray area is the real representation of the synaptic weights for the hidden layer and for the output layer. And as we have seen, the white part, the binary part, we have 2 parameters, alpha and beta. Remember that alpha is the probability of observing 0 and beta is the probability of observing 1 for each of these parameters. And the gray, we have the pulse of each weight defined by the center of the pulse and the width of the pulse. So this is the basic structure, the general structure. We have all the inputs in my database, and I'm going to select all which are the best or the most suitable for the neural network. Here is the H number of neurons that I'm going to define which one will be active and also the activation function of these neurons. And the same goes for the output. The output, this was done for classification, so I know how many outputs I have, okay? But I also want to define what is the best activation function. And of course, the real part will define all the weights in here and all the weights in the hidden layer, okay? The idea is the same configuration of the evolutionary process. The only modification is that now we have a multi-layer perceptron here instead of a recurrent neural network, but the idea is the same. And here the only difference is that the evolutionary process, now we have the hybrid, so we have to do apart from the binary and apart from the real representation. So that's why we have this, we have to take care that when we are evolving the binary part, if a neuron is inactive, so of course no evolutionary process is implemented with that neuron, okay? And sorry, and here is the update of the binary part is using that, moving that arrow that I mentioned in the beginning. And here is the same idea of moving the pulse in the right direction. So here, very briefly, what has been done with this case study. It was basically for classification using benchmarks just to evaluate the accuracy. So we use this, this number of classification problems. These are the number of samples. These are the number of inputs. We can see that you have many inputs and a number of classes. And this is the basic training process, how to evaluate in order to compare with other models that has been already presented in the UCI. So these 8 cases, these are the average of all the evolutionary process, okay? This is the best value. And we also did some statistical analysis in terms of to evaluate if these values are really statistically better than the other authors. And 8 cases actually resulted that are statistically better, the quantum evolutionary process. 8 have equal, and only in 2 cases that the quantum inspire presented the worst results, okay? Also, to show you how this can be used in echo state, I'm going just to describe briefly what is an echo state neural network. As I said, is a recurrent neural network, not in that fully recurrent process that I mentioned before, but this is from the reservoir computing structure, let's say, where you have the hidden layer is actually a reservoir where you have random connections here. So that's why it's recurrent here. And it contains then this reservoir, which is dynamic, completely non-linear. And this reservoir has a large number of neurons, but not all of them are connected to all of them. So it's sparse, but the connections are random and fixed. So these are not learned. You randomly connect this in a random way. If you have 100 neurons, you define a percentage of connection, let's say 20% of connectivity, and then this is randomly created. And it's good because the only thing that you have to learn is the weights from the output, which is much easier. Okay, so only the output layers are actually learned, and the reservoir is fixed from the beginning. And the idea is to preserve this dynamic memory of the reservoir, so that's why it's recurrent. But although it has very good results and it's easy to train because it's very fast, you only train the output layer, but you have to tune the hyperparameters as the size of the reservoir, the percentage of connectivity, and some other parameters that are really important and has a great impact on the performance of the neural network. So defining these hyperparameters and also determining the good reservoir, because you initialize with different configurations and you have to test your neural network. So it's difficult. At the end, you need to do a lot of testing as well. So that's why we want to evolve this and do it automatically as well, okay? So for those who are not aware of these echo state neural networks, as I said, we have the input, of course, from the problem you have some input attributes, okay? This is the reservoir, which is created randomly. And you have connections from the input to the reservoir. Inside the reservoir, you have connections, but remember that those connections are not learned, okay? And that's why you have these, which are the feedback connections. And you have connections from the reservoir to the output layer. You can also have connections from the input to the output layer. And also have feedback connections from the output to the reservoir. So these are all the weights that you can have in your reservoir or in your echo state neural network, okay? So this is how you calculate the state. Basically, just for you to understand, you have this leak stage, which is a parameter very important. And this is from the reservoir, X is from the reservoir. So you have, I'm sorry, it might have a background noise here because we have a car passing and providing a very strong noise, but I apologize. But then you have these feedback connections where your state in K depends on the state of the reservoir on K minus 1. And you have also the function of the reservoir based on the inputs and based on the weights, you have the feedback weights, and you have, if you do have them, you have the feedback connections here. So this is how you calculate the state of the new state of this reservoir, and then how do you calculate the output here based, of course, on the activation function as well, and based on the input, if you have these direct connections, and the state from the reservoir multiplied, of course, by the weights. Okay. So the important parameters that I mentioned that are really, they have a great impact on the performance. And usually you need to test a lot of configurations, different configurations, to try to find the best performance. And the parameters, the most important ones are the size of the reservoir, okay? The percentage of active connections. So what is the connectivity inside the reservoir? How you're going to actually normalize these weights, not only from the reservoir, but also the normalization of the weights from the input and the feedback, and that liquid state, which depends on the previous state of the reservoir. So these are the basic parameters. And what we wanted to do is to use the quantum evolutionary process to find the best parameters of the reservoir, those parameters that I mentioned here, but also to find the best reservoir. So after the hyperparameters are defined, we go to a phase 2 in order to define what is the best reservoir based on these parameters, instead of keeping randomly trying to find the best ones, okay? And this has been applied to system identification, which is very important in applications like control. You need to define your control system that you want to control, and you need to do the system identification. We have applied to 9 different benchmarks, okay? And I'm going just to show you 2, just for you to understand how the data collected from these, for instance, flexible arm robot or this team generated 2 different problems with different inputs and outputs. And you can see how the neural network is evolved and is able to find the best configuration totally automatically. So 9 benchmarks, and this is basically the parameters of the evolutionary process. So the size of the quantum population, as I said, is always much smaller than usually in the evolutionary process. Number of generations and other parameters, okay? So this is basically the flexible arm, but details you can find here about the problem. But in this case, it's a simpler one. You have only 1 input and one output, but I need to find what is the model that, given this input, provides this output, okay? In order to compare with other benchmark models, we use the same division in terms of training, validation, and testing. As you can see, the testing is actually half of the number of samples. So the training is much smaller than the testing, is what I want to mention. And in here is the comparison using the mean square error. And as you can see, based on this evolutionary process and based on the echo-state neural network, we found a much smaller mean square error, automatically finding the structure and the configuration of the neural network. Okay, and these are the best hyperparameters, for instance, that were found to solve this specific problem. And here is just the training. As you can see, of course, in the beginning of the training, the reservoir is still learning the memory, but then after it has a very good performance, and the validation and testing, the performance is really very good. And the other one is just a different kind of system identification. But in this case, we have actually 4 inputs and 4 outputs in order also to find the function that maps this vector into this vector, okay? And again, in this case, the quantum evolutionary process provided the best results in terms of this function that was used in this specific case study. And you can also find some details of this system identification problem in this paper, okay? And here are the 4 outputs and how, in the testing, of course, the neural network provide all 4 inputs with a very interesting performance in terms of error, okay? Now I want to focus on the most recent work we have been doing, which is the use of all these evolutionary algorithms, but now to evolve the convolutional neural networks. And in this case, as I mentioned, the name that is now being used, because we are not evolving the weights, we are just although just is, it's really a difficult job, but we are just focusing on the architecture. That's why it's called neuro-architecture search using the quantum evolutionary process. Well, and as you know, you have seen many papers recently, convolutional neural networks is provided a fantastic success in terms of several tasks, not only in image recognition, but also natural language processing and everything. And you have many different architectures, okay, that have been developed with excellent results, okay. However, the design of these networks requires a considerable knowledge and time from an expert. So the expert has to try and to devise the number of convolutional layers, actually the size of the kernels, and many other things. So it's really time consuming. So this network engineering requires the expert knowledge that we not always have an expert in trying to find this best configuration. It's time consuming and it takes a lot of trial and error, okay? So that's why the neuro-architecture search is being provided, and many people are working on this area in order to reduce the time and trying to make it more automatic to find the best architecture. And in this neuro-architecture search, it has been used reinforcement learning methods and also evolutionary methods. But again, the computational cost is still a very big problem. And in order to reduce the search space, many neural network architecture search are based on grouping small blocks. So you have implicitly some expert knowledge as well to first devise these small blocks, and then the search space is reduced. And the idea to find the best architecture is based on grouping these small blocks, okay? So basically you have this meta architecture and you provide these blocks which reduce the search space. But then, of course, the structure of your neural network is limited. It's not as general as if you have totally freedom to find the structure, okay? So the idea was to use this quantum evolutionary process also in NAS, in neuroarchitecture search, because this quantum evolutionary process usually has a reduced evolutionary problem. It has it's less time consuming to evolve, okay? And we wanted to verify the applicability of this quantum in NAS, in neuroarchitecture search. So I just want to emphasize that in this case, we are evolving the architecture, okay, the structure in terms of number of layers, type of layers, and some hyperparameters, but not the weights as it has been done in the previous cases. So now the weights will be learned in a learning process common to convolutional neural networks, but not evolved in here, okay? So just for those who are not aware of the details of a convolutional neural network, I just want to provide very briefly the idea. So basically we have this convolutional process, and I think this figure provides a better understanding. So you have an image and you have to define kernels, okay? So you have to define the size of the kernel, but the convolution operation is very simple. You use this kernel and we multiply this by the image. So you have this feature map, okay? This is the convolution process. So basically what you have to define is the kernel size, the M&M, the stride, how many bits you're going to shift, and the number of filters, basically this, okay? And the stride is basically how you are going to shift, how many bits. In this example that I provided here, we are doing basically the stride is 1 or 1 bit, but you can stride 2, for instance, or different strides, okay? And basically after the convolution operation, we have, of course, an activation function. Usually we have this ReLU, which is basically pseudo-linear, where you have the maximum of 0 and x. So it's 0 below 0, the x value 0, and then it's a linear function, okay? And after this convolution, we have the pooling, okay? Usually you have a process of doing the pooling layer where you have to define K and S as well. K is also the size, can be 2 by 2, and also the stride. So you, in this case, you do a max pooling, for instance, you get the maximum of this square, 2 by 2. So the maximum value here, sorry, the maximum value here is 3, the maximum value here is 2, and you can do it for the whole image, okay? So a convolutional network is actually formed by repeatedly stacking this convolution and optionally pooling layers, okay? So this is, for instance, one of the very famous convolutional network, which is AlexNet. So you have different convolutions, you have pooling, sometimes you don't have pooling. And at the end, after the convolution layers, you have the fully connected, like an MLP, for instance, in order to define your classification at the output. So the idea using the quantum evolutionary in this process, the QNAS, is to find the best architecture. So we have the input, we have the output. These are established by the problem you have. But then what we are going to put in here? What type of convolution, the size of the kernel, the stride, and also the pooling, what type of pooling, it's completely free. And also, as I said, not only the structure, but the hyperparameters of the learning algorithm, for instance, the decay, momentum, etc. So we want to use the evolutionary process to define the configuration, the topology, and also the hyperparameters. So basically we define the set of possible functions we want. So we are going to define the size of the sorry, I received a chat, but I don't think there is any problem. Can you hear me? Is there any problem in terms of the connection? Okay.
We are able to hear you.
Okay. So we define a set of functions that we have in a pool of functions that will be evolved by the evolutionary process. and also the range of each parameter that we want to search in this range. But the final value will be defined by the algorithm, and the final structure will be defined by the algorithm. So based on these function sets, what we do, I don't know why it stopped. Now it's working. So let me try to go back to here. So as I said, based on this set of functions, at the end of the evolutionary process, we will define that, for instance, the first layer will be function 3, then at the end will be function 1. Of course, at the end of the convolutional network, we have the classifier, the fully connected, and all the parameters have been defined. This is what we want. So the evolutionary process is also hybrid in this case, because we have a numerical space for the hyperparameters, and we have a categorical space for choosing the functions. So the numerical parts will define all the hyperparameters of the learning algorithm, and the categorical part, the network structure. So this is the basic algorithm, very similar to all the others. So you initialize the algorithm, and you have the evolutionary process by a certain number of generations. And the evolutionary process is basically to generate the classical individuals from the quantum population, remembering that we have these two parts, okay? The part of the hyperparameters and the part of the neural network. Then you evaluate this classical population. We will see how to evaluate. Actually, we train for few epochs in order to evaluate, in order also not to take a very long time. And at the end, based on this evaluation, we update the quantum population in order to adjust the quantum population in direction of the best solutions, okay? So the numerical hyperparameters is the same as in the quantum-inspired evolutionary algorithm with real representation. We have the square poles, and you define the lower limit and upper limit. And then you define the quantum gene based on these two parameters, okay? And the numerical part has the traditional arithmetic crossover, and it changes the update operator of the quantum individual, change the poles in order to shift the poles in the direction of the best solution. So for this parameter, for instance, the best solutions of the classical individual are between 0.6 and 0.8. So the poles, the initial poles, is shifted to this region. And of course, as I said, the area of this pulse has always to be 1. So if the pulse is narrower, then of course it has to have a higher value, okay? So we change the position, and we change the width of the pulse. And the categorical part, category representation, as you see, is a chain of L size, fixed size. So we define the initial number, maximum number of layers. It can be 100, it can be 50, whatever, but it's completely free to define the functions of each of these L layers, okay? So you have a pool of possibilities. You define, I want to have a pool of different convolutions, of different size kernels, of different strides and everything. And not only in terms of convolution networks and pooling layers, not networks, sorry, convolution layers and pooling layers, we also have NOP operation, because a no operation layer, because if you define 100 layers, for instance, maximum, at the end you can have only 10 or 12 because of this no operation function that can also be used by the evolutionary process. So basically this is, instead of having a probability density function, in this case we have a probability mass function, but basically you define how many options, categories you have, and then you define this function, okay? So the idea of this observation process, let's say you have 3 nodes, you define that your network will have 3 layers, and you have a pool of 5 different functions that are here. You have a convolution 132, you have a max pooling 22, and you have a no operation layer as well. And if you have a quantum individual that node 1, layer 1 has these probabilities for each function, node 1, node 2, you observe this, okay? And let's say for node 0, you actually define that it's going to be function 1. For node 1, it will be function 5. And for node 2, will be function 4. So you decode this, and then function 1 is actually convolution 1132. Function 5 is no op, and function 4 is max pooling 22. So the resulting or the final is basically this, okay? The categorical part increase the probability. I'm running out of time, but basically you update, you increase the probability of the best solution. So it was 0.2 here, it's going to be 0.25 because this was the best solution. This is the process. You generate, you evaluate. The evaluation, as I said, you train for very few epochs in order to define the fitness function, and then you terminate. And after we terminate, we actually retrain that specific architecture for then more epochs. That is the idea, okay? Just to finalize, I'm going to show you very briefly the result of these in the benchmarks of CIFAR 10, CIFAR 100, and a real case study, which is in seismic data, seismic classification. This is the configuration, some parameters, the function types. We have, as I said, convolutional blocks, pooling and no-op. The initial probability is 1/3 for all the convolutions, 1/3 for the pooling, and 1/3 for no-op. This is the initial probability, and of course, this is changed. This is just some images from CIFAR 10, but just for you to know, CIFAR 10 is because we have 10 classes, 10 different classes with images from airplane, automobile, and etc. These are the basic functions that we provided as options for the evolutionary process. And here is the result we have in different configurations, also using residual layers. And here is the result when comparing with other NAS approaches, okay? As you can see, the result here is not the best one, but in this case, the freedom of the architecture is, the degree of freedom is higher than some of these, because some others, they have those blocks that have more functions in it. And here are the hand designed models, okay? And here is just this 93, which was the best of the configurations of KNAS. If we use the retraining with a certain learning rate updating of other models, which is specifically for the CIFAR 10, we can reach even higher accuracy automatically. Okay, this is just the change in the probability of each function. The CIFAR 10, of course, CIFAR 100, sorry, we have 100 classes. And in this case, we use exactly the same parameters of the CIFAR 10 study. So we didn't change those parameters. We also use an early stopping. And in this case, we reach 0.74 in terms of KNAS. And this is very close to other approaches like max out, this, and ResNet has 75%, which is higher than what we have done in terms of automatically approaching, okay? And the last one is a real classification problem. This is a seismic data, which is important for finding, for instance, oil. You do this seismic analysis, but we wanted to use not only benchmarks, but also a real problem. And we want to have an image and classify if this is a reservoir of oil or this is a different kind of soil, okay? And of course, this seismic, it's very big data, it's enormous amount of data, and we need to learn from very small size of annotated data, okay? And we compare with a hand-designed convolutional neural network. And in this case, the results in terms of accuracy, we reached 0.98, which was the best accuracy in the quantum NAS. And this was the handmade. So we were able to find a better architecture than the handmade one, okay? So final remarks, this quantum-inspired evolutionary algorithm has really a shorter convergence time, which is very suitable for this neuro-evolutionary process. It's scalable, and it provides, it's possible to do neuro-evolutionary process for different types of neural networks using supervised reinforcement learning. You can evolve the input variables, the topology, synaptic weights with a faster convergency than usual evolutionary process. And this fast convergence is also suitable for online learning, which we are also doing in other experiments. And we have also applied this quantum evolutionary process to other hybrid models, such as fuzzy evolutionary models, and also in multi-objective environment, okay? I'm sorry, I passed a little bit of time, but if you have any questions or if you want to contact me, please, this is my email. And now that's it. Thank you again for the invitation. Okay.
Madam, there is a question from one of the professor, madam. Sir was from Tokyo. Sir was a speaker for the previous session.
Yes, yes, of course. What is the most important orientation point in QIA? Is it continuous value instead of binary or coexistence? Thank you. Actually, Kira, it's interesting your question, because the main difference is not because it's real or it is binary. The main and the most important difference is that now your evolutionary process is not based on a gene that has one specific value. So in a standard genetic algorithm, you have, for instance, a binary representation. The chromosome in that gene has a value of 0 and has a value of 1. So that's why you need many different chromosomes. You need a bigger population because you want to map the search space with many different chromosomes. Using the quantum evolutionary process, each chromosome actually does not represent one solution, but it represents many solutions at the same time, because that gene is not one point in the search space, but is actually a superposition of all the states. Actually, you could use one chromosome with the quantum gene, and you map all possible solutions, because one chromosome in the binary, I'm using the binary because it's easier for you to understand, but The same applies to the real representation. But when you have a chromosome with 2 quantum bits, those values that define the probability of observing 0 and the probability of observing 1 actually maps in one chromosome all 4 states that 2 bits can represent. So one solution represents also, one chromosome, sorry, represents all possible solutions. So you don't need a huge population size, you don't need a very big number of generations, because one solution, one chromosome maps a very big number of solutions at the same time. And the evolutionary process actually changes these genes and changes this probability in order to direct your solution to the most promising region of each gene. I'm not sure if I respond to your question, but that is the idea. How is it related to different evolution, which is used for optimization? Yeah, it's different. It's completely different. Actually, this quantum evolutionary process is similar to those probability estimation evolutionary process. The difference is that in CMS, sorry, is that they usually use one single chromosome that represents all solutions. It's a probability distribution function, okay? But in here, the difference is that we use more than one chromosome just to help in the evolutionary process. But the quantum inspire is more similar to, as I said, to those estimation distribution evolutionary algorithms, not to differential evolution. You have many different evolutionary computation models, like genetic programming and on others. It's a different, actually, another student of mine some years ago, they developed the quantum inspired for genetic programming, but it's different from what I presented today. I don't know if there is any other question.
There is one request from Rajaram Reddy Naidu, madam. He's asking, can we get this PPT?
Yes, I can actually, can I send to you, Naresh, and then you can distribute?
Yes, sir. Yes, ma'am.
Okay, I will send you via email, and then you can give to all the attendees that are interested, no problem.
Okay. So I think there are no more questions.
Okay, thank you very much again for the invitation. And if you need any other, if anybody wants to contact me via email, feel free to do so.
On behalf of Hyderabad Deccan ACM chapter, I would like to take this opportunity to place on record my heartful thanks to you, ma'am, for sharing your valuable knowledge on quantum-inspired evolutionary algorithms. And you have clearly explained various types of neural networks with case studies. Thank you so much, madam, for accepting our invitation and for being with us. Thank you once again.
Okay.
Madam, once will you stop sharing your screen?
Yes, sure. Thank you again for everything.
And there is one message from Sudha ma'am. Thank you, it was wonderful. And Rajaram Reddy Naidu sir is saying thank you, madam. Madam, there is one small memento from our chapter, madam. A virtual memento is being shared to you. Please accept it.
Oh, thank you very much. Okay.
Really, it was a wonderful session. Thank you, ma'am.
Thank you.
Tilottama madam. Tilottama madam. Tilottama madam.
Yeah, hello.
Good evening, madam.
Yeah, good evening.
Shall we start the session, madam?
Yeah, I was
Yes,
not
ma'am.
able to unmute myself
Yes,
just now.
yes.
Good evening, everyone.
Dear participants, we will start the next session. Let me give you a brief introduction. Tilottama madam. Dr. Tilottama Goswami has over 20 years of experience in industry and academia. She received her doctorate in computer science from the University of Hyderabad, MS in computer science from Rivier University, New Hampshire, USA, and BE honors in computer science from NIT Durgapur. Presently, Dr. Goswami is working as professor in Department of Computer Science and Engineering at Anurag University, Hyderabad. She is senior IEEE member in IEEE Hyderabad region, CIS GRSS chapter, and associated with Hyderabad Deccan chapter as Vice Chair. As an active researcher, she has delivered guest lectures and workshops conducted by AICT faculty development programs, IEEE summer schools and workshops, Center for Development of Advanced Computing, engineering colleges in the area of artificial intelligence, machine learning, computer vision. Her recent works have been published in reputed journals, book chapters, and conference proceedings. She worked as a software engineer. During her doctoral studies, she worked as software engineer to assist in the project leadership for a funded project by Indian National Center for Ocean Information Services under the Ministry of Earth Sciences, Government of India during 2012-13. Dr. Goswami has been awarded University Grants Commission Basic Scientific Research Fellowship under Government of India during 2014-15, and Dr. Goswami is recipient of Risto Society for Research International Women Researcher Award. We welcome you, madam.
Thank you, ma'am. Am I audible?
Yes, ma'am.
I have shared my screen.
Yes, ma'am.
Are you able to see the?
Yes, yes, ma'am.
Okay, okay. Thank you, Shweta, ma'am. And good evening, all the participants. Today, my talk is on the introduction to the artificial intelligence and machine learning, and I will briefly discuss about the machine learning tasks and the algorithms. Then I will tell you which functions, which packages in Python are used for your programming for machine learning. And in the next half, Ms. Uponika Barman Roy will give a demonstration from start to end with one ML project. So this is the flow which we have planned. So let's, yeah, after Dr. Marley's talk, actually, that is basically discussing a particular architecture, a model, a technique in a machine learning. Here, I will just give you an overview from the starting. So what is AI/ML, this agenda? The first part is what is AI/ML? What are the key tasks? How, so if how ML is a part of AI, but when we need the learning, when we do not need learning, that part we'll discuss. Briefly about the statistic methods which are used for ML model training, which is very important, those two concepts, and the applications. So this is basically the history. So it's 7 decades of artificial intelligence history. Presently, it has become a very important subject in everyone's world in this computer science world. But it was already there from 1950s, and it has seen many ups and downs because every decade, every decade, the challenge kept on changing. So the challenge which was there is 1950 was already solved by 1964. So similarly, the task which we think is impossible now, but maybe after 2 decades, that is already achieved. So if you see um, the whole problem statements which are there in the artificial intelligence, that is constantly changing, and every time we are able to find a solution, so we go ahead with a more challenging task. So this is the brief history of AI. So you can just find it out. So this particular place where I'll say AI winter. So the AI winter is the time when we found that the AI couldn't move forward because of some limitations. So what was that limitation? So actually, when there was a problem where there was a non-linearity, then that was not able, we were not able to tackle that
Madam,
non-linearity.
madam,
Hello? Yeah?
madam, have you shared your PPT, madam?
Yeah, I told you. I thought you were
Just
told me
your
to.
folders. I'm seeing, ma'am. That's it.
Oh, no, no,
You
no,
didn't
no.
open the PPT.
Yeah, yeah, I opened it. One second. Is it visible?
Not yet, madam.
Now
No,
I am doing the same.
yes, now it is okay.
Now it is okay. Okay. So basically, when there was a non-linearity, the problem famously known as the XOR problem. So it was not, we were not able to solve it with the early AI. So here this particular neural networks was found in 1985-95, where it was told that that XOR problem can be solved if we are having a hidden layer. So before that, it was just the simple perceptron into was developed, but later on the neural network with hidden layer solved that non-linearity problem. So AI is basically, briefly, I would like to say AI is artificial intelligence. So what is artificial intelligence? We are trying to be like a human, correct? So it is thinking humanly, thinking rationally, acting humanly, acting rationally. So all these four things, if we are able to achieve, then we can say that we are actually competing with a human. So how you know that whether we have achieved the capacity of a human? So for that, we will see there is a Turing test. So in the Turing test, basically you give a problem statement to a human and to a machine, and then try to get the solution of that problem. So the human interrogator here, left hand side, if you see, is not doesn't know the solution is coming from a human or a machine. If he guesses that this particular solution is from a machine, and he truly finds out that it is, and he makes a wrong, basically a wrong guess that okay, this solution is from a human, but it is from the machine, then that particular Turing test will tell that the machine is able to bluff the interrogator, and the interrogator thought that the machine is actually a human. So this Turing test, in honor of Alan Turing, who is the British mathematician, we can tell whether this particular problem has been solved or not, and whether that intelligence quotient which we are trying to find in a program has been achieved or not. So this is what about the thinking rationally. So the laws of thought, the rules of derivation comes into picture. Before that, as we have told, thinking humanly, cognitive science comes into picture. Then acting rationally. So acting rationally means we are trying to maximize a particular goal, so that we can achieve. So any there will be many options or many paths, ways to solve a problem, but do we act rationally or no? So that particular rational behavior also has to be taken care by the program. So as I told you, the state of art, every time the challenging problems keep on changing from one decade to another decade. So if we say the tic-tac-toe was a very easy thing now to solve using the uh, computer programming. Even if you see the playing chess also can be achieved by the computer. So, but now what is the challenge in the artificial intelligence? So that those problem statements we have to take care in the coming decade. So here, if you see, the major components of AI is we have to represent the knowledge, then there has to be a reasoning, so this will be a rule based. Then there is a language understanding. So when we are communicating, whether I am able to understand the language or not. And there is a learning. So the learning is when you are having certain data and you learn from that data. And if you are not having data, then what you will do? So the thing is, if you have less data, or if you have more data, and if you have no data, so there are many situations which will tell us then the methodology as how to learn. So similarly, as a human being, when we start with 1 year old to 80 years old, the learning process is always there. So when we are young, the data is less, and the capacity to reason and understand the language is also less. Slowly the learning becomes powerful, learning becomes robust. So when you are having a learning, robust learning, then you can with less data also you can go ahead and do the reasoning. So this is all about the Turing test which I just have discussed. So areas of AI to work. Now, the thing is, these are the places where we can work. Natural language processing, as I told you in previously, that here the language understanding, how would you communicate? So this is the natural language processing. Then knowledge representation, automated reasoning, machine learning, vision, and motor control. That is the total Turing test. Total Turing test means it's not the computer. It is basically a movement where you are able to move from one place to another place, and also you are able to reach the target with even if there are obstacles. So all the robotics part comes into picture for the total Turing test. These are all the foundations of AI. All these subjects, basically the mathematics and statistics, play a foundation role in the artificial intelligence. So the Turing test, if you see the test of intelligence, as I told you, this is a very important and interesting Venn diagram, where there are cases when the human is not that intelligent. Whenever we are talking about artificial intelligence, not all humans are intelligent. So here, when we are competing with the intelligent person, this particular overlapping, the pink color is the human behavior that is not intelligent, and the overlapping one, the purple color, is the intelligent. And then there are also cases where even we are intelligent, but we cannot, we are not capable of doing certain tasks because we have some limitation. Say for example, we cannot just go to the Mars and study it. We still need lots of research work to achieve that. So this is the intelligent behavior which is not displayed by humans. So this particular part is also there. So if a particular machine is able to achieve two things, one is the capacity of the human intelligence is also showcased, and the limitation which the humans have, that also can be surpassed by the program, then we can say that it has passed the Turing test. So recent applications in the AI, you will find the bots, which is a short form of the robot, and there are many opportunities, business opportunities, if you are using these chatbots. Or it is not only chatbot is usually very popularly used term, but there I would like to tell you that there are chatbots, crawlers, transactional bots, informational bots. So basically these are certain specific functionality which can be achieved for a particular task. Then there are bad bots, there are good bots, there are bad bots. The bad bots are hackers, spammers, scrappers. So these are small um, specific applications in AI, which uh, which are which actually help in the business also, and also streamline our work, and in a efficient manner. So that's what I was talking about, the robot, the smart bots to intelligent bots. So this is where uh, you will be using machine learning, natural language processing, because if it is complex bot, then the learning, if it is there's no learning, so that means it always acts in a fixed manner. There is no adaptability. Okay. So the intelligent agents are autonomous, no human intervention is required, and it will be on its own, controlling as well as taking decisions, everything it is doing on its own. So now the thing is, everything started with the artificial intelligence. Then what is machine learning? So in the machine learning, what happened when that all the time AI task doesn't need learning. Say you have a data D, capital D, and it is a huge data, and you just want to extract some information about that data. So you can use the basic statistics, descriptive statistics, and get to know the um, mean, median, um, or any other statistic values from that data. So it is not a learning, it is basically extracting information from that whole data. Now the thing is, if you're part of the environment, in that environment your data is less, it is incomplete, and you would like to assess whether the environment, you try to assess the environment, but you are having less data. So if you see only little bit of the data, you try to start guessing that, okay, maybe the next data which comes up will be of this same pattern. Okay, so you are trying to guess and learn, and then suddenly you see after a time frame, some more data is put into that particular environment. So you again learn, okay, so now I have got the same pattern, say some particular balls, red color balls, black color balls was initially given, and after that you are thinking that there are only red and black color, but after some time there was a white color ball. So then you guessed, you are trying to learn that there are some multicolored balls in this particular environment. So what happens in machine learning algorithms, in the environment when you have some incomplete knowledge because of the scarcity of the data, and you would still want to extract some information, then you as a human being, similarly that algorithm also starts learning. So if I have given some data, some idea about the data, say as I told you it is red color, black color, then you, it is supervised in the sense I have given you only two colors. But if I didn't give any color and I have given you some 2 3 objects, and I am not saying that this is ball or this is bat, but still you are able to separate them, but you don't know their name, ball or bat, but you are able to see two patterns there, so it's unsupervised. Then there is a reinforcement learning where you have to have a, like a game. You have seen the video games. Similarly, the gaming where you are trying to maximize the awards, there it is not a task as such, there it is always in a continuous process of taking decision every step to maximize the award. So everywhere you will see that the learning is not the whole thing in artificial intelligence. Wherever the learning is there, that part of the AI is called the machine learning. So these are the all the domains where the AI is used. Now in the case of deep learning, so as this workshop is mainly on the deep learning, tomorrow we will see the artificial neural network structure. Presently this shows the future trend. What is the future trend means? Here this feature extraction is automatic. So it's basically the representation is automatic. As I was telling you, if I have ball and a bat, then I can take some features of the ball, some features of the bat, say the dimensions, the shape, or any other parameter, and then train them that if it is a circle in nature, then it is ball, something like that. But now consider that I am not telling anything about their parameters. I am just giving their image as bat and a ball, and automatically the feature is extracted from the algorithm. So that is the feature learning. Okay, so this is what is happening in the deep learning. So the automatic feature extraction is there. So in the machine learning concepts, basically the inputs are called predictors, independent variables, features. These are all similar in nature, and output variables are called responses, or dependent variables are all are the same. In the output, it can be quantitative or qualitative, categorical, discrete, or the factors. Quantitative means it is a numerical number. Qualitative, categorical means good, bad, spam, not spam, uh, grades, something like that. So the learning from data. So why I want to learn what I want to learn? I would like to learn that if I given some data, in from that we will do a feature extraction. After that we will train the that particular set of features is having a particular output quantitatively groups. So this is one where you are doing a supervised learning, where the output can be a quantitative or it can be a categorical. So in the supervised, when you are having output as a quantitative, then we called it as regression. When it is qualitative, then it is called a classification. So basically, if you see the regression here, if you are given a point, you are trying to fit in a line, and here in the classification, you are trying to separate out these two categories. So wherever you are having some data, it depends on what data you are having in your algorithm. Now unsupervised. So now the data is how the data is organized, we have to find out, and we are not told any output. Labeling is not there. We are just given a data, input data, and we have to find out how it is different. Say for example here, if you see all these faces are there and nothing has been told which is happy, sad, angry, nothing has been done, but you are able to find out a pattern, or you are able to say cluster. The word is cluster, which you use usually in the unsupervised uh, learning. So this is how is done. Similarly, in the next one also, if you see the balls, automatically it is telling that there are three categories. So then there are ML tasks, as I told you, you can classify them as spam or not spam. So it is categorical. Then there can be object detection, then train each example, weather forecasting, then news classification. So these are some example of the classification tasks. Then there is an example of regression. So this is, you are trying to predict a numerical value, the price of the stock or the price of the gold, similar to that. Then you are also having this another example where these sceneries are there. You are trying to categorize them. Then collaborative filtering, that is recommendation systems. That is another very good use, very popularly used. Then there are image retrieval. So given an image, are you able to retrieve the similar images? So this is the categorical, whether email spam is categorical, dog cat is categorical. So you just see this uh, example, and it's actually a quiz. So we are running out of time. So this is basically, I'll tell you the answer. So this is the categorical output, email spam, dog, and wherever we are having a prediction in percentage, that becomes quantitative. Then the stock price prediction also becomes quantitative. Okay, so this is the mathematical definition. I won't go into much of a detail because as we are telling, there are, this x is input variable, there is a function which fits this input variable and gives an output variable. So this fitting function is actually the learning that target function. So any particular function which takes this input data and gives that output is actually trying this y can be, as I told you, the y can be your categorical, or it can be also a numerical. Okay, so this is the training data. Okay, now as I told you, what is training data? Training data is xi, yi. That means x means input, y is output. So if I have told the shape is circle and its color is red, then yi is ball. The shape is rectangle, the color is white, then y2 is bat. So for every set of features of a particular object, we are labeling it with yi. Okay, so first of all, we will be training the data, and then only we will go for the testing the data. So this is all the supervised learning. As I have told you, these are all the features, and output target is whether it is malignant or not. So that means this is a classification problem, whether it is true or false. So this part above part is the learning part and bottom part is the testing part. If you see, same features are there, the feature vector is same, but now I don't know whether it is malignant or not. So if my model, cancer model, is trained using this bigger matrix, then I should also be able to predict for this test data. So the integral parts of the ML model training. So when I try to train, basically there is parametric and non-parametric. So in the parametric function, the algorithms that simplify the function to a known form. Okay, so here you are given some parameters and you are trying to fit into that. So it is also called high bias. Okay, so you have already made it a bias. So that means you already tell, actually, these objects are black in color. So that means you are biased now. So you always think that a particular face, if face recognition, the hair will be always black. So it is a bias which you have fit into it. But if you take a non-parametric, you do not make any strong assumptions of the mapping function and you are free to learn. So according to non-parametric, you do not say any values of the features that this should be. So usually it is used for the distribution parameter, like whether this follows a particular distribution or not. If it is, say for example, it is a Gaussian distribution, then it will say, actually, this marks which this class has got, the mean is 70% and the standard variation is plus minus 10. So some parameter you have given which is telling you about the Gaussian distribution. But if it is non-parametric, you do not tell anything about that assumptions. So the non-parametrics algorithms have a high variance and a low bias, whereas parametric have high bias and low variance. So often more flexible and achieve better accuracy, but requires a lot of more data for training. Obviously, if I have not made any assumptions, then you should have lump sum of data to understand it. Okay. So let me go fast about this. So this is the central limit theorem. In the central limit theorem, if you see here, so in the central limit theorem, it describes the characteristics of the population of the, so these are all the population of the data. These are very various shapes of it. Okay, so the thing is, it will always, the central predicts the, regardless of the data of the distribution, the mean of the population is always equal to the mean of the parent population. So if you say increase, see the shape, it will take a normal distribution. So here, if you say this, actually parent population was like this, and you have taken samples, then the mean it is telling and the standard deviation for any parent population. If you just draw, it will tell you the mean and the standard deviation. Okay, so this is about the central limit theorem, and here it will tell it. So this normal Gaussian distribution helps you a lot in understanding the nature of the data. Okay, so the well shaped curve is the normal Gaussian distribution, and if you have one standard deviation, that is plus minus 1, mean is 0, then it actually captures 68% of data. Plus minus 2 standard deviation captures 95% of the data. Plus minus 3 captures 99.7% of the data. So this is one example of the IQ. And law of large numbers, as the size of the sample is increased, the more accurate of an estimate the sample will be to the population. Say for example, if you have a class of 30 students, you take 3 or 4 marks and then you say this is the mean. So that is not correct. So if you take 15 of them and then if you say the average, then it may be near to the population mean. So the sample is a part of the subset of the population. So the more the sample you take, the more you are able to assess the nature of the population. So why these law of large numbers, central limit theorem we are discussing in machine learning? Because we have to train in such a manner so that because when you are training, you are not taking the whole population, you are taking a sample from the data. Okay, so if you are taking a sample from the data, which sample represents properly the whole population is very important for training. If you have taken only a small amount of data and you train, and then the test data comes from another end, then obviously your model will fail. So that's how it is implicable. This one, overfitting and underfitting is also very important, that whether your model is overfitting or underfitting. So the thing here is which model is good. What happens if you are considering each and every feature to make a decision? Say for example, if you want to know the person for a campus recruitment, the features taken where the midterm sorry, the semester marks. Okay, but now you take class 1, 2, 3, 4, 5 to 12 marks also. So you are trying to overfit. It is not necessary that you take 1, 2, 3, 4 up to class 12. Only semester 4, 4 years or 8 semester marks are good enough to understand whether he can do the job or not. So if you are taking extra features and trying to fit that also, then it is overfitting. What is underfitting means you are taking only the last semester marks. Okay, so there will be deficiency in the model if your model is trying to overfit or underfit. Okay, so this is again, you can go to the example. So basically this part is done. I will show you quickly about, because now I have only few minutes left. Let me see here. Is it visible, ML concepts?
Yes, madam.
Okay. ML concepts, classification, regression, clustering. Are you able to see the screen, madam?
Yes, madam.
Okay. So basically, as I have already briefed you, I'll just take a very short 5-10 minutes time only. Classification algorithms are there, regression algorithms are there, clustering algorithms are there. As I have told you, we are here dealing with supervised and unsupervised. Okay, madam, can you mute yourself, please? Yeah, thank you. Thank you so much. So the classification and regression algorithms are basically the supervised algorithms, and clustering is your non-supervised algorithms. So these are the list of algorithms. So classification algorithms, regression algorithms. So now you will tell that how I will program. So if you are using some of the scikit-learn libraries, then directly you can go and use the package with there. So now this is logistic regression. So the logistic regression is a statistical method. So if you have a data set where there is one or more independent variables that determine an outcome. So your cross and the circle is there. So you are trying to fit in a line. So this is called the function. As I was telling, G is the function here. Okay. So G is the function. So here you can see this is underfit. Why? Because some of the crosses are going into the other side and some of the circles are coming. So it's not perfectly classifying. But if you see the third one, it is overfit. It is and the complexity of the function is also increased. See, if you see the polynomial, it is of higher degree polynomial. So higher degree polynomial, it will take time to solve the problem. Okay, but the middle one is the ideal one. There is error, but it is less error. whereas left hand side it is more error. Right hand side being a complex function, it is having no error. So we have to choose that till what threshold of error we can mm, accommodate. Depending on that, the complexity of the function can be decided. Another is a linear regression problem. In the sorry, this is a regression, linear regression. So here we predict the scores of one variable from the scores of a second variable, and we are trying to predict here. So this is called the regression problem. So finding the here best fitting straight line through the points. So if this is the lines, and everywhere you the error term here is the mean square error, we can calculate. Then naive Bayes, it's also supervised learning, which uses the Bayes theorem. So depending on the Bayes theorem, where you are having the prior probability likelihood, you calculate the posterior probability. So basically, if you are having the here yellow here and the green here, and now this is the question mark in the bottom diagram. If you say this question mark, so the question mark will be what? Whether it will be green or whether it will be yellow. So you calculate the probability of the green and probability of the yellow, and then decide whether it is yellow or the green. So it is probabilistic reasoning. Then there comes a decision tree. So this decision tree can be used for classification as well as regression. Okay, so here you can you will take the decision on each feature and choose the next level in the tree, whether it is so you will have certain decision making at the node, and then you will go to the according to the result of the decision, you will choose the next layer. So it is graph based. So this is the graph based. So here you can classify or as well as predict. Then there comes the k nearest neighbor. So the k nearest neighbor is also a simple algorithm which classifies new cases based on the similarity measure. So here the distance functions are used to assign with the particular class of an object. Then comes the support vector machine, which is very one of the very important supervised machine learning, which also can be used for classification and regression. So basically, you are trying to find a vector which vector hyperplane which separates the two classes. So the it's finding a hyperplane that differentiates the two classes, and it can be done in the n-dimensional space as well. This is the clustering. Clustering is a unsupervised. So in the clustering, you can do this unsupervised learning. So here, if how good is the model? So once you have trained, then tested, then how you will know whether the model is good or not? So there are these many performance matrices in classification models. Okay, so these are confusion metrics, precision, recall, accuracy, F1 score, AUC, ROC. So there are so many things. So which one to use depends on the problem statement, but usually the accuracy is very common. Precision recall is also common. So and it you can generate any one of them, and say for example, if you are having a research paper where they have shown confusion metrics, you want to compare with them, so that time better to go with the confusion metrics and compare the results. So you can also think from that point of view. Then for regression models, the performance metrics are different. So for classification model, performance metrics is different. So for regression model, this is the mean square error, root mean square error, mean absolute error, adjusted R squared. So these are not going into details because it's a very short time to go into details for each and every ML tasks and in details. So I'm just giving you a brief So next, when we are showing you the program demonstration, that time it will be clear. So now, as I was telling about the scikit-learn libraries, how I will use it. So you have to you import the package. So similarly, you can for logistic regression, you can use sklearn linear model. You import logistic regression. You just have to write this from sklearn linear model import linear regression. For naive Bayes, Gaussian NB, and for regression also, as I told you, naive Bayes can be used for both classification and regression. For k nearest neighbor concept can be used for classifier, then you have to import k neighbors classifier. For regression, k neighbors regression. Then for decision trees, it is called CART because classification and regression trees. So it is used for decision classification as decision tree classifier, and the class is decision tree regressor for the decision trees. Then support vector machine, SVC. And this one is SVR for regression. So for the k-means clustering, you have to import k-means. Then there are some different types of clustering. You can use the import. So if you ask which is better, which is not, so sometimes what do we do is we experiment. Experiment. You use, say for example, you want to do regression task. You use all the five of them. And now how you will know whether which one is good? You go to performance metrics, choose any one or two of them and see what are the results obtained when you have used any one of these regression models, and then take a decision. So this is the conclusion. We have come through various concepts of machine learning algorithms. Fundamental is all about the data. So on basis of various categories of the data, the task of prediction is either classification, regression, or clustering. There are multiple algorithms, and each one of them overperform the other in various criteria and handle the data distinguishably. And ultimately, it's all about playing with the data and perform various tasks. So your data is nothing but a sample from the main population. So if you are choosing more data, then it becomes more close to the population and your model gets trained accurately. So that's all from my end about the brief of the machine learning algorithms and how, why you need a machine, why you need learning, and what is artificial intelligence. And yeah, that's what. Any questions? Thank you.
Naushad Rahim, he is asking, can you please share the slide? The same question again and again.
Yes, yes, I will share the
All the
slide.
materials are uploaded in Google Classroom and the
Yes,
section 3.
Google Classroom, it is there. I have already uploaded it in the Google Classroom.
Kavita madam?
Shall shall we then go ahead with the demonstration?
Yes, ma'am.
Okay. Thank you, ma'am. Thank you, everyone.
Thank you so much, madam. That is a demonstration. Will you do it now or else in the Google Classroom, madam?
No, no, no. Once I think only half an hour it will take. Miss Uponika will be doing the demonstration. The code is already there. She will demonstrate. Uponika, are you there?
Yes, yes, I am here.
Yes, yes. Over to
So,
Uponika.
yes, thank you, ma'am. It was a wonderful talk. So, okay, so now we will be seeing the demonstration where I have taken a use case of from the classification. So first I'll share my screen. My screen, is it visible?
Yes, ma'am.
Okay, thank you. So as I was telling, so in this Google Classroom, we have already uploaded all the materials, and also if you can see here in practical what I will be showing right now as a demonstration, these two notebooks are this notebook is also there, as well as the data set associated with it. So for this session, I will be telling how to run one classification algorithm on a particular data set. So for that, I have taken a data set of diabetes.csv, so that I have shared here. So first, before getting into the notebook, I would say how to import the data set to the notebook. First, if you open the So this is, if you open the link, and you have to open through the Google CoLab. So my account is already signed in. So otherwise you have just to log in with your email ID, and then your this is the notebook that will open. So once that is done, then we can import the data set that is there. So you need to go, and again the same thing. So I already have the dataset downloaded, so I'll just import from my local file system. So you just need to click in this folder. I'm showing this because it will be helpful to you when you will do for your assignment 2, which is followed by this session. So here will be your upload sign, and once you click over here, your local file system will be opened. So here there are various, so this is the data set. Yes, okay. So ensure once you are importing the data set, if you are just running, closing this entire session, closing this entire collab, your data set will no longer be visible, will no longer be stored to this. So you once again have to do that. So once that part is done, so this is all ready. Okay, so now before coming into the classification example and talking about the codes, I would just take a carry forward from what ma'am was explaining to her previous lecture. Uh, for the ML task that which comes under a part of AI, we have supervised and unsupervised learning. So under the supervised learning, classification is one of them. So we have classification, we have regression. So what is classification is denoting what is regression. So regression is when we need to predict something which is continuous. Say for an example, you have say for an example, if we consider a house price, so depending on the different features, like what the location of the place, and what is the what how many rooms are there, and how much floor space it occupies, so on basis of that the house price happens. So suppose for an example you have 10,000 records, 10,000 data is there, that for this particular features the expected house prices certain x value. So now for if you have one particular new data, it will be able to predict what can be the expected house price. So that is what is a regression, where you are predicting the value which being trained in the previous set of data. Classification is something which does with a discrete output, where it maps whether a particular thing is yes or no, like a true or false, if it is a binary. If we can it can also be a multi-class classification if we go for something like more than two possibilities. Say for example, if I have today is rainy day or it is a sunny day, it depends on the weather temperatures, the humidity, then different other factors. But for an example, if the what kind of vegetable it is, so that depends on the shape of the vegetable, the different the color, the taste of it. So there are different other factors. So on basis of this, it can be a multi class, it cannot be only two. So for this one, we have the example that we have taken is a diabetes data set, which is a binary classification. So what it does, the data set has been collected from UCI directory, and from there this is a vast directory where you can collect any kind of data set that is available over there, and you can simply just download, go to the website, their website, and download the data set from them. And once your data set is downloaded, to start with the classification problem, first we need to get into some the libraries, and this entire example is shown with the scikit-learn in the background, and Python as a programming language. So for now, as we have discussed about Python language in the previous lecture, it is quite a bit clear like how the Python language is used in the different scenarios, how the list functions, how the different other like string, how these are working. See, for an example, there are Python, as I was mentioning in the previous session also, that it has a Python is vast. So in that you have to select which kind of domain you want to go through. So if you are coming into this machine learning and sklearn, so they have their own libraries for each and everything. It has its own library. So these libraries are important to import. Once you import this library, then you can use this library's functions to make your job done. So for an example, we will be using few libraries that it is very important to get accustomed, because this is a statistical format of machine learning. In the later part of the workshop, you will be going through the deep learning, where it will come into an advanced and cognitive way. So it is the first library that we can see here is the pandas. So this pandas library is a very effective one, where it has lot of functionality. So gradually, with the flow of this example, while explaining, we will be coming to see the power of this library. NumPy is a kind of library which is used for the numerical any kind of numerical arithmetical uh, operations that we do with our data, which can be, and these PD and NP, PLT, these are the alias name. So these are helpful in making our job easier. Like we don't have to write every time pandas dot to import the function from this library. So just a PD dot will work out. So that's why we have kept some alias name in it. Matplotlib is a visualization tool library where you can visualize your data, which is very important when you are working with the data. Unless you are visualizing your data, you will not be able to work with it. So you just need to visualize that what, to understand the quality of the data, to understand how much raw it is, and to understand how much you need to clean your data. So before getting into any algorithm, it is very important to clean your data, to understand the data, and to work on the data, to analyze it. And Seaborn is also one of the visualization. So we will be seeing these libraries to be used in the later part of the code. So the first thing that we need to do once this environment is set up, that we need to load the data set, which we have already imported and kept in our system. So that to load a data set, first we will run this code. So once that is done, we have this data set. So the data set name it is in the CSV file format. So you can see over here pd.read CSV. So the PD pandas library is used, and along with that, the associated function is a read CSV. If I'm giving this function, this is able to import the data set into your environment where you are working. So it got imported and got stored in a variable called data. Now we have to, before getting into the data, before getting into any kind of thing, we will understand the data. What is there in the data? So data.head is a function. Head is a function which tells us, which gives us the flavor of the data, which tells us what is there in the data set. It won't give you the entire data set. For an example, it will just give you 5 or 6 instances. Having said that, I mean there are different records. This is number 1, 2, 3. So there are different records of data set, and there are these are the features. The columns are the features. So what are the features we can see? We can see pregnancies, glucose, blood pressure, skin thickness, insulin, BMI. So all these features is resulting to understand and to tell whether the person is diabetic or not. So if I'm mapping this for only one particular instance, I can understand if these are the conditions where my pregnancy level is 6, glucose is 148, and so on and so forth, and age is 50, I can predict that this person is diabetic. So outcome is, see, if you can see, it is within zeros and one. So it is a binary classification. So a lot can be understood from this data.head, where you will be able to understand the entire data set, at least get the overview of the data set, like what are the features are associated with it, and what kind of classification it is expecting, what is the outcome, whether it's a binary or multi-class, or what is the different types of the data, and so on. For different thing you can understand from this data.head. So if you just give one more, say suppose for an example, I need 10 instances for 10 number of records. So just give the number of records that you want. So 10 number of records, the first 10 will be able to come because it is the head. So the first 10 will be coming. Next, let us come to the next part. It does the same thing. It gives the records. It shows the data set, but from the uh, downside, like from the tail. If I am just giving, say for an example, if I'm running this cell, if I'm just running this cell, it will be able to give me the last 5 data set. Okay, so the last 5 records will be coming from it. So suppose for an example, here also I want only 10. So see, from the last I am getting 10 instances. So data.describe. So this is one more function which tells us about the number of rows and the number of columns. Here, if I'm not considering the serial number and the outcome, so how many number of features are associated to predict whether the person is diabetic or not? 1, 2, 3, 4, 5, 6, 7, 8. So except our outcome, there are 8 features which are predicting whether the person is diabetic or not, and there are total number of instances is 768. This thing we can also understand from data.ship. And also there is one more thing that you can add over here. If I just give a data.info, this gives us the entire description of the data set. It tells us how many what are the number of entries, that means the number of features, and from what to what it is happening. And also it tells us what are the different columns, so I can get the column name at hand. And at the same time it will tell me the data types, at what kind of data types they are, how many are float data types, how many are integer data type. If you can see the data type, we have 2 float data type, this one, the BMI, and this function, this two are my float data types. So we are having 2 float data types and 7 integer types. How much is the memory usage, and most importantly from here you will be able to see whether we are having any null values or not. This is very important. This is a part of a data analysis, and before we are getting into any ML algorithm, the basic part that we need to do is EDA, that is an exploratory data analysis. So when you are doing an EDA, this is a major part where you have to look whether the data is a null values are there in the data or not. Because if there is any null values, then we need to work on that. If there is a lot of deficiency of data, then we need to work on that if there are in any of the feature. So that comes in another part where you have to how it has to be fill and all these will come to the another part. Now let's see what is the statistical. Now from this we can see some statistical insight. We can see the correlation, we can see some mean value, standard deviation function. So what are all these things, like how the correlation is happening? So how far this pregnancy is related? So I this is just a mapping where one feature is related to other feature. Okay, so like how one is aiding, whether this function, whether this feature is aiding the other feature or it is opposing the other feature, how far it is doing the work. So for an example, if I consider pregnancy and glucose, so you can see it is a positive 0.129. That means it is aiding. So what if there is an increase in the pregnancy level, if there is there is a chance of increase in the glucose level, and vice versa. But if you see in this case, if there is a skin thickness and the pregnancy, there is a minus 0.08. That means this factor is opposing this factor. So if there is an increase in 0.08 factor, in 0.08 value of a pregnancy, we can see that there is a decrease in this skin thickness. So these are the different factors by which we can correlate. It is better to always go through a visualization. So whenever you just go with a visualization, which anyway in this time we cannot cover a visualization, but if we go with a visualization, it becomes more clear how this correlation factor affects in the prediction. These are some general way to calculate the statistical factors. What are the mean values of the entire of every feature? Say for all the features, what are the mean values of respectively, and some standard deviations. So these are very important when you are working with the data, when you are cleaning the data. So and also this is a part like what is the value count, how many zeros, that means how many non-diabetic patients are there and how many diabetic patients are there. If you remember, there are total 768 entries were there. So out of 768 entries, there were total 268 patients are diabetic and the rest 500 patients are non-diabetic. Now there is also one case study where we can also think like if the data is balanced or not. This also comes within the EDF. Later on we can maybe in some other way we can see like how to balance the data and all, but this is also a way to understand whether the data is balanced or not. If it is not balanced, we need to balance the data set. Now the next part, let us come to the leveling of data. Why do we need to label our data? Because this is our entire data, but we are only interested with the features. We need to know what is our X and what is our Y. Our X are my features which are independent, and my Y is dependent to all my features, some function of my X. So if I know my X and Y, for an example, if I take X is data.drop, what does this function do? See, if you just place your cursor over here, it is very easy in Google CoLab or any Jupyter notebook. You will be able to see the documentation of this and also the how to write the code for it. So if you just take a data.drop, so it is taking in the X all the features except outcome feature. So now outcome has become the result. So that is my Y, and Y is taking the data for outcome. So the feature of outcome is stored in Y, and rest of the data, which are all the features that is going to predict whether the person is diabetic or not, is coming and storing under X. So that is how I labeled it. Now let's see what is splitting the training and the test data. So once this part is done, now we have total 768 entries. You have the entire bulk of data. Now how much part do I need to train and how much part do I need to keep my data for testing? That varies. If you already have one set of test data, then you can keep the entire set for training. But if you do not have any kind of test data, then you can use this data. You can just uh, divide this data into two different half. First, training data. In the training data, keep the maximum number of entries, because more number of time, according to the law of large number, more number of data points it will train, the more perfect the prediction will be. So if you train more, your data will be more correctly predicted. So for an example, for it is by default, it is always considered if you keep a test size 0.2. What does that mean? Test size 0.2 means out of 100%, 20% of your data is used for testing, and the rest 80% of the data is used for your training. That is a bulk amount, right? So but for that you have to import one library function. This is from the Scikit-learn library.model selection. So if you are just importing this train test split, this function itself will help you to split the entire data. And these are the parameters, these are the variables in which you are splitting and storing. So if you are using this trend test plate, and within which you are passing these two values, that is x, which you have already labeled with which you have already collected as your feature set, and y as your outcome, and then you are dividing the data as for like x train and x test. What does that mean? It means that some percentage of data, within 80% of data, your x is the x matrix give your feature set, and the x test, this matrix, is the outcome of that feature. And this y train and y test is for the rest 20%. For the rest 20%, the features are your y train and the result is your y test. Now let's see how it works. So as we have seen from the previous lecture of ma'am Tilottama ma'am, we could see that there were different algorithms that we have there for the classification, regression individually. So for the classification, we have different algorithms like logistic regression, naive-Bayes algorithm, SVM, decision tree, and so many. But we are not getting into each the functionality of each algorithm. But for an example, if I tell you that if the person is diabetic or not for this particular data set, if I'm using this particular function, if I'm using this particular algorithm, it has its own unique way of identifying whether the person is diabetic or not. Similarly, it will be done by the decision tree, by the decision like graphical representation, as it was shown. Support vector machine by the dimensionality. It will go into n number of dimension to find whether the person, from the features, it will find whether the person is diabetic or not. Naive Bayes, it will check with the other with the Bayesian algorithm, it will check whether the person is diabetic or not. So there are different examples. Say for an example, I'll take this logistic regression. You will find all these functions in the Scikit-learn libraries. So I'm just importing this function from the Scikit-learn library. So before that, let me just run these cells. So yes, my data is now ready. It got splitted into 80% to 20%, and then I'm importing my logistic regression algorithm. And then see, data check is an object here, which is taking my logistic regression function that I have imported from sklearn libraries. Now in this data check, this object is trying to fit my x train with the y train. So it is trying to fit the whatever the data that I have kept for splitting, so that 80 and 20% it is trying to fit. How it is fitting, that is another part where you will be seeing that how the data is getting fitted to the training algorithm, and the test how it is trained. So it got trained. So whenever you are giving a dot fit function, it itself will train the data and it will fit it. Now, this Y predict is doing what? This Y predict is taking that from the 20% of data, it is taking that feature set, that is your X test, and it is doing a prediction, and we are giving a predict function to predict that test. So that is my Y predict. And what is the correct value? We should know what is the correct value. What is the difference? So we have a Y test which is there to compare with whatever we have predicted. So Y test is my actual result that is expected, and Y predict is what the algorithm is predicting. So when I'm comparing this Y predict with the Y test, I'm getting the actual ratio. This is giving me a ratio that what percent error is there, what percent is not yet correctly predicted. That percent I'm taking into a sum. Okay, and then this I'm using a accuracy. Accuracy is again it's a type where you are finding what kind of what is the percentage and how much is how much good is the prediction happened. So this, till this part you have predicted, but what next? You have to know whether you have corrected properly, you have predicted properly or not. So for that you need to know the accuracy of your prediction. So that prediction of your accuracy is your correct by length of y-test into 100. So that is nothing but giving it into a percentage. So once that is done, we can see how much percentage it will take. So it is 77.27% it has predicted. Okay, now let's see the same thing. The here it is the same way how it is fitting. At first it is trying to fit the training algorithm, and then it is trying to predict on the test data. Once it is tested, then it is trying once it is predicted, then it is trying to find how much correctly it has predicted. For that you are finding with the accuracy performance matrix. So for a decision tree, it is 68.83%, okay, which is lesser than this logistic regression. Now let us check with the support vector machine. Now for a support vector machine, it is always into a dimensionality. So for example, if you have, if you are having a lot of data, then it will be taking, obviously it will go into n number of dimension. So for an n number of dimension, it may take you a little bit of time compared to the other algorithms, classification algorithm. And here it is, the kernel is linear kernel, and as we see, as we have mentioned, that for a classifier we require an SV support vector classifier. So once the data is fitted, it is again predicted on the X data, and once that is predicted, it has come with the correction with how much is the accuracy level. And similar goes with the naive Bayes. For the naive Bayes, it is 76.30. So we can see it is the SVC which is giving a more accuracy, just little bit more than this logistic. Yeah. So the SVM is giving a more accuracy than any other level of any other classification algorithm. Now this part you can also increase your level of accuracy. You can also increase your algorithm to predict much better. These are done by changing the different hyperparameters, whatever. When I'm telling hyperparameter, so these hyperparameters are always coming to each of your algorithm. When you are importing the algorithm and you are initiating your algorithm, you can make changes in your, see, if you are keeping over here, so there are different smoothing, if you can see word smoothing. So these are the different hyperparameters. So different changes of this tuning has to be done, so that it is like a trial and error to get into more and more better way of predicting. So this was an end of our classification task. This was just a simple way of showing how to load a data, how to just check, make some certain very basic level of data analysis, and after that how to get into the test leveling of the data, and then training and test data splitting, and then to fit the algorithm, I mean fit the data into the algorithm, and once it is running, how to predict how much is the accuracy. So this is a very basic level. Whenever we need to do any kind of classification modeling, we go through this thing. So and more, because there are a lot to explore in the EDA. Lot of more your data is clean, more better result you can expect. So EDA has to have a lot of focus, and also to the tuning of the hyperparameters for the algorithms. So this were the classification, an example of the classification in our further session. But before that, I would like to know if there is any doubt regarding any of the portion that I have explained so far.
Hello.
Yes.
Hello, madam. Hello.
Yes.
Okay. Done with your demo, madam?
Yes, the demo is done. But I would like to know any doubt from any one of the participants.
They didn't ask any doubt. There was no message in the chat box, ma'am. There is no question. Participants, if you have any doubt, you can please post it in the chat
Okay, I
box.
can see one
Please
doubt. Please
show
show
how
how to load dataset. Yeah. So yes, you mean how to load the dataset in this collab or within this one, or you want to like tell me this thing?
not code but in
Not
collab.
code, but in code. Okay, okay, I got it. Yeah, so I will show you. So this is the diabetes. See for an example, if you do not have this file. Okay, so first the thing is you just, this is your collab. Go to this folder and there is an upload button. Just click over the upload button and then you will get into the downloads, your local file system, wherever you have downloaded your dataset. And then once your download is done, so this is the dataset in my local system. So yes, it is reflecting here. So once it gets reflect here, that means it has got imported in your collab. And if at all you are still facing any other still issue, then we also have a video. In reference video you will be able to find, we have posted 2 reference guide. So here in this videos you can able to find how to do that. Yes, you have to download that locally. That's why in this classroom, we have uploaded the diabetes.dataset. So download the dataset. It will be in your downloads folder.
Okay. Any more questions? Participants, do you have any questions? Thank you, Tilottama madam, and thank you, Uponika madam, for your clear explanation about ML and demonstration about this demonstration on Scikit-learn. As we
Thank
have
you.
another session. Yes, ma'am.
Yeah, thank you for the patient hearing. And we have uploaded all the documents, videos, references, quizzes, and also the assignments in the classwork. Any doubts if you have, you can write it in the classroom itself. We will reply you.
Okay. Ma'am,
Thank
now
you,
they
ma'am.
have to submit another assignment, right, by 8:30?
No, no, they can at the end of the workshop.
Okay.
So by tomorrow they can do it. You
Okay.
have told about the assignment, Uponika?
Yes, I was just about to tell. So
Yeah.
this is one assignment where you will be having 2 dataset. This is a dataset petrol consumption.csv. This is on a regression, and spam based. This is a classification dataset. So just take one dataset and just do the whatever I have shown like a demonstration, that the same way you can just first load the dataset and then work on the dataset using any one of the algorithm, either classification if it is a classification dataset, or if it is a regression. The instructions and everything how to do is you will be finding in a document, in an instruction guide document. Otherwise it is also there, like whatever the demonstration I have shown, from there also you can open this file notebook, and you can try to refer this notebook to complete your assignment too.
Participants, I think it is clear to you. Thank you, Uponika madam and Tilottama madam. Uponika
Thank
madam, will
you.
you stop sharing your screen?
Yes.
So as we have another session of Tilottama madam tomorrow, now I am presenting a token of appreciation to Uponika madam. Please accept it. And from Naushad Rahim, it is thanks for the session.
Okay, welcome. Okay, thank you so
Please
much.
accept this token of appreciation, madam,
Sure, sure.
from
Yes.
Hyderabad ACM chapter.
Thank you so much. Thank you.
Thank you. Tilottama, madam. Yes,
Yeah,
ma'am.
tomorrow we will, today we are done for the day, correct?
No, no, madam. At 8:30 we have another session.
Yes, for this our session, this one is
Ah,
done for the
yes,
day.
yes, ma'am.
Yeah,
Yes,
tomorrow I'll be taking the deep learning.
yes, ma'am. Okay. So participants, please join by 8:20. Today you have that session by Risto, by Professor Risto. Please join by 8:20. Thank you all. Tilottama, madam, shall I end the session?
Yes, we can again join at 8:20.